So it's 5 past the hour, so I think we can start. So welcome everyone to the new edition of the RISE Summer School. It's a great pleasure to see so many of you online, and I hope there's also many of you that have joined one of our local hosts. So the summer school, as you know, is going to be running throughout this week from 2 to 7 Central European time. And it's very great to see many of you here. And I want to start this session. It will have two components. First, an introduction about MICCAI, and then an introduction about the RISE, what we try to do, and how we came to create this summer school. So without further ado, I would like to introduce our first keynote speaker, Dr. Marius Linguraru, who is the current president of the MICCAI Society, but also he serves as the Connor Family Professor and Endowed Chair in Research and Innovation at the Children's National Hospital in Washington, where he leads an AI research initiatives. But he also holds a faculty appointment as a professor of radiography and pediatrics at the George Washington University. Dr. Lingaro has had multiple awards, and I just want to mention a few of them, which include the Excellence in Engineer Award in the UK Houses of Parliament, but also he has co-founded a company, Pediatric Metrics, which has a focus on improving pediatric health throughout AI. And I think I can continue expressing all the many awards that he has and all the great work that he has done. But I think I'm going to let him introduce Mikael, as well as maybe talking about himself a little bit more.
Thank you very much, Esther. Hello, everyone, and hello from Copenhagen. So, excuse me, I'm just setting up my camera. I am at the IEEE Engineering and Medicine in Biology conference, a meeting that some of you may know. So I just stepped back into my hotel room for this excellent event here. So just bear with me very briefly as I'm getting set up. But first of all, I wanted to say thank you to Esther, to the RISE-MICCAI board for all the excellent work that they're doing. And I had a great pleasure of interacting with this associated board of the MICCAI Society a couple of times in the last few days. We also did the seminar, the journal club for RISE about the LISA challenge. And I'll mention that briefly as well today. But most importantly, today, I wanted to give you a flavor of the many flavors that the MICCAI Society brings and things that the society is offering and things that we would love to welcome you to do together with us as part of the society, as part of the initiatives like RISE, activities for students, activities for women in MICCAI, and many of the working groups that we have. And I'll show you a little bit about all this. And let me see if I'll bring my slides together so that we'll move to something a little more visual. And please confirm that my slides are showing up correctly. Yeah, thank you. Thank you, Esther. So let's start first with a few words about the society. And for everything that I'm going to mention today, you can find more information at miccai.org. And if you are not too excited about the way it looks at miccai.org, I have good news. We're setting up a new website for the society that I'm hoping is going to be partly ready in time for our conference this year. So, up that. I'm sorry. Up. So my keyboard is acting up. All right, we got it back in action. So first, just very briefly, what the MICCAI Society is. First of all, I think everybody knows medical image computing and computer-assisted intervention. But what is important to me, and I think to all of us, is the leading international forum for research, education, and practice in the fields of medical image computing, computer-assisted interventions, but also machine learning in medical imaging, and also applications to robotics. And the MICCAI Society has been running basically for over 20 years, but it had an earlier start when there were different groups and meetings that eventually converged together to create this society. So basically the society established itself in 2004 and is led by a board of directors, and I'll show you in a moment who the board is, has about 2,000 members, and they come from more than 55 countries, which I think is very exciting. And I'm hoping that with the initiative like this, we're going to welcome more of you and hopefully from new territories as well. Our members come from academic, clinical, and industrial research organization. And here we also increasing our diversity, and I tell you, many of our members are young, and that's I think very exciting as well. And I wanted to show you here a map that we pulled last year at MICCAI 2024 that shows where participation or participants to the conference came. And this shows a lot of the world map in green, again, which I think is exciting. Actually, Greenland should have been green here as well, because we obviously had participants from Denmark. But the diversity of our society, I think, is at the heart of the work that we're doing and something we want to grow and to encourage. And our board of directors is led by an executive leadership. And other than myself, and as Esther introduced me, coming from Children's National Hospital and George Washington University in Washington, D.C., Linwei Wang is from the Rochester Institute of Technology, and she is the executive secretary of the board. And Shahai Zhuang is from Fudan University, and he is our treasurer. But this all sounds good and dry. So let me tell you a little bit who I am and how did I become the president of the MICCAI Society. And I have here two pictures that are very important to me and speak a lot. The first one to the left about my childhood and how I grew up, and the one to the right about where I am now. But if we were together in one room, I would quiz you if you could guess what these two buildings have in common. But like this, I'm going to tell you straight away, they are both pediatric hospitals. So the one to the left, I see a hand up or somebody ready to answer that. So the one to the left is the pediatric hospital in Sibiu in Romania, which is the old capital of Transylvania and is where I grew up and where I was raised. My mom was a pediatric nurse, and she was the head nurse of this hospital. And this was in Romania during a dark period behind the Iron Curtain when childcare wasn't at its best. So I spent a lot of time at this hospital, hanging around my mom's office. So I saw a lot about pediatric care, about the sadness and the difficulty of being sick as a child, and about things that were missing in the care of these kids. So what did this mean for me? I didn't want to be a doctor, and I didn't want to deal with kids. But life moved in different directions. So I ended up to the pediatric hospital to the right, which is Children's National Hospital in Washington, D.C. And although I spied at my parents and I didn't want to be a doctor, I went and studied computer science. And how did that take me? So as a computer scientist, after doing my initial studies in Romania, I moved to England and I did my PhD at the University of Oxford, where I started to specialize in medical imaging. Before that, I have done a master's degree in parallel and distributed processing systems, where I learned about AI in healthcare. But this was a very different era of AI and what you're learning in school, right? Very different than what you're exposed to today. But I worked on the detection of breast cancer using very much models of the human eye, mathematical models of the human eye that in time translated more into artificial intelligence models of how to interpret radiological images. From there, I crossed the channel and I moved to France, and I worked at INRIA, which is a National Institute of Research in France, where I worked on brain imaging, this time looking at the mad cow disease. That was the time when the mad cow disease was very, very scary. And fortunately, we don't have to worry that much about that disease. But that's what my postdoc was about. Then I crossed over to the United States, where I spent the last 20 years of my career. And at Harvard, I worked on ultrasound imaging. So you hear X-ray, MRI, ultrasound, right? Very, very different applications. But this is what I learned also, how the reality of childhood sickness looked at Harvard, where I assisted in my first week there to a surgery on open heart surgery for a 9-month-old boy that had the best care possible and the best surgeons possible, and what looked to me like the worst utensils, because these utensils were not designed for pediatric surgery, right? There are things like many things that we see in healthcare. What's done for adults doesn't always work that well for kids. Then I moved to the NIH, where I worked in a more general radiology image analysis. Multi-organ analysis was my passion. And again, artificial intelligence was important at this point to my work. And finally, for the last 13 years, I've been at Children's National Hospital. So during this period, something that was really important also was my exposure to MICCAI. And if my keyboard comes back, my first MICCAI was in 2001. That was in Utrecht in the Netherlands. And pretty much ever since, I hardly missed any of these conferences. MICCAI has really become my professional life, and I hope you will do the same. But you may also remember me from last year in Marrakesh. If you attended there, I was the program chair at the MICCAI in Marrakesh. The first time the conference went to Africa, also something that I'm very proud of, and also something where we had an emphasis on healthcare equity. This is not just because kids are disadvantaged, right, in healthcare, and this is my area of work, but also because access to healthcare, to digital health, to technology is definitely unequal around the world. And through this society, I think we can do better all around. But pediatric healthcare, right, is again at the heart of my work. And at Children's National, if you remember Dr. Bear is a sponsor of MICCAI this year again. So Dr. Bear is going to finance scholarships, full scholarships, maybe for some of you who are here today in the audience, to attend MICCAI 2025. And so we did last year, and our lab at the hospital is called PI, or Pediatric Accelerated Intelligence. But that's enough about background. I want to show you what does it mean work in pediatric accelerated intelligence. Here are some examples. In health equity, I think it's important to do accessibility, availability, fairness, and quality and efficiency. And some of the projects that we're doing that have a broader scope is like the app that I'm showing you here to the left, Engine, that is identifying through photography to a simple snapshot kids at risk to have a genetic condition. We have a project right now in Kinshasa, in the Democratic Republic of the Congo. We published a study in the Lancet Digital Health with data from 30 countries. So that's a big picture for us. Another thing is a project that we're doing now with funding from the Gates Foundation, like you see here at the bottom right, using ultra-low field MRI. This is this machine here, this R2D2, and we presented work about this last year at MICCAI, Austin Tapp, our fellow. This machine works as 64 mini Tesla. If you work in the field of MRI, you know that most clinics use 3 Tesla. So this is far, far lower in magnetic field strength, but also is much cheaper, it's much lighter, it's portable. So R2D2 acquires images like the one you see to the left here. You lose quality by losing strength field in MRI. So what we do, we use artificial intelligence and we superfill these images so they look like the image to the right. So we make them of diagnosis quality. And we work with data now from thousands of children, mostly from sub-Saharan Africa and South Asia, with a project called Unity of the Gates Foundation. Something else important to me, and you see I'm focusing more on applications that we do on areas with limited resources, is this picture here shown on the front page of the Washington Post of a portable ultrasound machine connected to a laptop with an AI algorithm, and this platform without Wi-Fi, hardly with electricity. In Uganda, we are screening for rheumatic heart disease, which is a complication of the heart from strep throat that, if it's identified early, can be very easily fixed with antibiotics. But it's hard to identify early, and you don't hear it on auscultation with a stethoscope. So we are participating in a real screening program where AI will be evaluated as well, looking at 200,000 kids in the near future. But then to go back to MICCAI also, we also work in pediatric brain tumors, which are the most common cause of death for kids. And my team is here part of other winners of the BRATS PEDS challenge in 2023. And BRATS stands for Brain Tumor Segmentation. It's one of our lighthouse challenges at MICCAI. I'll show you in a moment. Last year, we won the competition on data from sub-Saharan Africa. So here is when we benchmark to these challenges, different algorithms, anybody can apply here, and then we look at which one is performing better. So now enough about me, and let's go back to MICCAI. This is our board of directors, and I'm hoping that you already interacted with some of them or you've known them. And if not, when you come to MICCAI, you'll get to speak with them. So Spiros, Albert, Martina, Jongzo, Karim, Gina, Nicola, Stephanie, Dan, Pinkun, and Mohammed are part of the board. And they come from both areas of MIC and CAI and from many parts around the world, as you can see from their affiliations. And we have also in our team, we have some of our very prestigious MICCAI fellows like Max Virkever, Terry Peters, Jim Duncan, and Alison Nobles. They are supporting the election process for MICCAI, the fellowship awards, and other awards like the Enduring Impact Award. And of course, this would not be possible without the great work that comes from our administrative staff, and Jeanette, Joanne, Kitty, Diana, Anna, and John are among those. So I have many words of thank you to everyone that I'm showing here, but more importantly, I want you to see their faces next to their name, because you see emails coming. If you submit it to MICCAI, you probably get lots of messages from Kitty, yeah? But knowing also who they are and interacting with them. And Jeanette, Kitty, and Diana and John are going to be in Korea as well at the conference, as all of our board and most of our fellows. So with the board, we have a number of working groups. And these are really important because these are some of the main services the society is offering. They are communications, conference affairs, education, diversity, career advancement, industry, and clinical. So with a little bit of time, I'll show you just very briefly what they mean. And again, you can find out more information on the website or by interacting with our board. For instance, communications. All the emails that you're getting and the announcements and the endorsed events are coming with our communication strategy. Branding is coming to this as well. So our social media, please engage with our social media. We'd love to have more engagement there. And when you see announcements on LinkedIn or X, on Twitter, and anything that happens about MICCAI, we'd love to have more of our engagement and to hear from you as well. Job postings and event announcements come to that. MICCAI Quarterly, it's also our way to communicate what's really important. This is our newsletter. And I think it's becoming more and more exciting over time. So when you get it, don't put it in your spam, open it, look at it. There are important things there. Like, for instance, we're going to hear about our web redesign, but also how our election process is changing. And this is in a way to get our community more engaged. And this is something that we're going to see also, for instance, for the first time at MICCAI 2025, we're going to have our candidates for the board present in front of the community to make the election more transparent. Where would you hear about this? On MICCAI Quarterly. So this was announced on the last MICCAI Quarterly. Again, please read it when you get a chance. Conference affairs. This is the working group that is looking at the organization of conferences. And of course, MICCAI conference is one of the main events of our society. So what's the timeline for that? How's the bidding process working? How to pass information from one conference to the other, how to work with the organizers. I know it sounds simple. It's not, because the conference has been growing a lot and we're trying to get engaging and useful event for everyone at the conference. So right now, there have been some changes. If you read MICCAI Quarterly, you found out that unfortunately we had to move away from the convention center in Hawaii because that convention center changed dates 2 years in a row. We were supposed to be there in 2026. They canceled they wanted to go to 2027. And actually that was even earlier. We were supposed to go there, 2026, 2027, and then they wanted to move to 2028. So because of that, we reopened the bids for MICCAI 2027. And now we're inviting bids for MICCAI 2028 to go to a new location in the Americas. So if you're interested about that, the notice of intent is in October. The education working group, of course, very important. And this is the working group that is looking at our endorse events and what kind of associations we have to have a society. It's organized in the MICCAI Fellows Talk series. And here is the one that was done by Nicolas Padois, in May, and these are regular things where you learn about very exciting work that is done by our fellows, and they are fellows of MICCAI for a reason, because they are doing very exciting work. There's also the relations with our special interest group that I'll also mention in a moment, and we're dealing also with other societies, so we're building more and more relations. For instance, we just signed a memorandum of understanding with the European Society of Radiology. So I think this will be exciting about seeing more clinicians at MICCAI, but also having them help us how to define better challenges, better things that are in need for the clinical work as well. And you heard this from me today. We're probably going to hear in the newsletter next week, or in an announcement next week. This hasn't been announced officially yet, but it will be out in the news very soon, the relation with the European Society of Radiology. The diversity working group is looking at exactly what we need to focus on, providing a safe and welcoming experience to all attendees, to the code of conduct, but also promoting participation from underrepresented groups and countries in our society. And this is also the group that is working a lot with our associated groups like RISE, like Women in MICCAI. We have also, I wanted to say, our code of conduct, both ethical and the scientific code of conduct, are very seriously taken at the MICCAI Society. If you have not had a chance to read them and to look at them, please do so. You have to abide by these rules, both if you present a paper or submit a paper to MICCAI and if you attend a conference. And again, this is done just to provide the right level of environment for everyone who attends the conference. The career advancement working group is very dear to me because this is something I started. And this is how I joined the MICCAI board 4 years ago to build this program. And this is based on the MICCAI mentorship program. This is how it started. This is also something I started together with Antonio Porras and with Alex Frangi, who was the general chair of MICCAI in Granada in 2018. We wanted to promote career advancement for students and also early career members of the society. This has grown into many directions since then, and it's bigger and bigger. And I think Antonio Porras is going to give you an overview of this, so I won't go too much into detail here, but just look at opportunities that can help you. And this can be grants or scholarships that we're offering. There's the Startup Village is looking at supporting companies as well. Again, we have the job boards, and now we have a platform as well, the Together platform, that will help you build and grow a relation with a mentor, or if you're a mentor, with a mentee through the Career Advancement Working Group. The Industry Working Group is building relation with our commercial partners as well, because we want to also be able to learn how to translate what we're doing well into commercial activities. And we have a series of talks here as well. This time you'll hear from industry leaders, and that's really important. And they bring a strategy of how to bring industry to the conference and how to help with sponsorship too. We have a clinical working group too. If industry is looking at industrial partners, clinical is looking at clinical partners. And they have a series of talks too. It's like the talk that was given by Tessa Cook that you see here in this picture. And again, these relations that we're building with other societies, but also to the CliniCai and MICCAI series, where we're engaging more and more with the clinical world to presentations as well at the conference. It's very important. So those are our working groups that come directly from the main board, and they are led by the board, but with a lot of help from society volunteers. The other big initiatives that we have are the associated boards, like the MICCAI Student Board, with initiatives to support students and early career scientists, Women in MICCAI, looking at strengthening and increasing participation of female scientists in the MICCAI community, and RISE-MICCAI. This is where Esther will tell you all about it. So I leave that to her. But some of the activities that these boards are doing, and this is, for instance, our student board in 2025, which is, again, very diverse, and they come from all parts of the world. They run the MICCAI Educational Challenge that you can see at the conference. They do a webinar series and a recent one has been about getting ready for MICCAI in Daejeon. They do the doctoral symposium at the conference, Emerge, the program also done for students, and lots of other events, including running events, industry events, networking that is done specifically for students, and fun events as well. They go out and they do some trips around town, so you can join those as well. So this is our MICCAI student board. Women and MICCAI, without surprise, has a board made of women, and this is the board from 25-26. They do a luncheon event at MICCAI as well, which is targeted to women and with very successful women in our field. They do a webinar series as well by showing stellar scientists, female scientists at MICCAI, and also some new awards they're doing for the best oral presentation and now for AI democratization. RISE-MICCAI, again, this is the board here. And again, thank you very much to all of you for the great work done, not only through this summer school, but through many other events. Like, again, the series talks, the journal clubs. But again, we'll hear more from Esther about this, so I will not insist too much on it. But I wanted to show you, because I was part of this too, this is the most recent journal club that RISE-MICCAI has done. And this is, I showed you earlier how ultra-low field MRI images look like. Now with these images, we are organizing a challenge at the second edition called LISA, Low Field Brain, Pediatric Brain Magnetic Resonance Image Segmentation and Quality Assurance. And you have here two QR codes. One is the main challenge run at MICCAI. The second one is the special edition of the challenge created and run for RISE-MICCAI. So this is something just for you, for the participants in the summer school and member of RISE-MICCAI, and with awards as well for this one too. And it's running on a different cycle so that it's organized around the summer school, so you can do the best of this to learn how to participate in a challenge, how to be successful in a challenge. And I think with an intro like this into the challenge world, then to be successful at the big challenges of MICCAI. And Esther, as I'm continuing, just a quick question. How are we on timing? Because I have lots of things that I can say, but I don't want to eat up any of your time.
I think you can go 5-10 more minutes if you want, and I think we
Okay.
only have one question for this, so it should be fine.
Sounds good. Please signal me without hesitation, yeah, when I should wrap up. We have special interest groups as well, and these are designed to bring researchers in a special area of MICCAI together at the conference and outside of the conference. And whether this is on challenges, on image registration, on ultrasound imaging, on cardiac imaging, on explainable AI, fairness of AI, on African scientists, or computational pathology, you see the diversity of these groups. And there may be other probably coming. So you can join any of these groups at any time and be an active member of these. Our other initiatives, so this is all that comes from around the board, but there are things then go beyond what is just a direct relation to the board, like the annual MICCAI conference. And that's our main event. And the MICCAI Society started around the conference, and this is still our prime thing to do and show as, again, a leading event in our field and specialty. And we have workshops, challenges, tutorials. We have things like CliniCai, which is the special track on clinical work. The Open Data Initiative has started last year. You can find everything on the MICCAI 2025 website, and I'll show you in a moment as well if we don't run out of time. Awards and grants. This is very important, I think, for RISE-MICCAI. Starting with the registration and travel grants, scientific paper awards. We have also the bigger awards to the Enduring Impact Award and fellowships, right, which are in acknowledgement of some of our most successful scientists in the society. Mentorship focused on career, on scientific development, capacity building in general, and startups as well. And then so many webinars like some of the ones I've shown you already. But here is the conference, MICCAI. And I wanted to show you how MICCAI has traveled around the world. And there are certain things I'm particularly proud of here. Although historically it moved a lot between North America and Europe, and you see it's been held there most of the times. more and more editions have happened in Asia, including 2025. That's going to be in South Korea. But we also had a meeting in Oceania in 2007, and I think 2027 will end up in this part of the world as well. We had, unfortunately, a virtual meeting in South America in 2020. You know very well why meetings didn't happen in person in 2020. It was still a very successful event, but not in person. We did not travel there in person. But last year, we were for the first time in Africa, and that was very, very exciting. And next year will be for the first time in the Middle East. So we want to be more inclusive and expand our footprint around the world, and we're counting on your help with that as well. Here, just a few things about how things have evolved at MICCAI over the last few years. And this is something that I had prepared for last year, so it does not include MICCAI 2025, but the previous 6 editions of MICCAI. And I want to show you that the number of submissions and papers accepted too is increasing and increasing fast. And now we are at about 20% more over here. But last year, we had 2,800 submissions. This year we had 3,700. So this is growing fast, and this is good and exciting. Papers come from all continents. I would love to see more increase in some of these very thin areas here. And I think with the RISE Summer School, with activities like Africa, like Mirasol, we're going to increase this. But otherwise, you see participation from everywhere, and we have a very big component coming from Asia. About half of the papers accepted at MICCAI have as a main author a man. I think our diversity has increased a little bit too, probably stayed mostly constant over the time. And again, we have women in MICCAI who are helping us reach more talented women in the field. If we look at ethnicity too, we also have a majority there, probably of Asian participation. But last year we saw small increases in participation from, African participants and also Hispanic. And again, I would love to see this growing more in the future. And what does it take to have a conference where you have 2,879 papers submitted? It takes over 2,000 reviewers, more than 150 area chairs. And in the end, we ended up having 857 papers accepted, and less than 10% of those are orals. And the majority of presentations at MICCAI are posters. And this is how MICCAI has always been. And posters are a great way to connect and speak with people and to learn about each other's work. But what it takes is a village, right, to be something like this. So this year we have even more people. So please do engage. We need good reviewers. We need good area chairs. We need the community to be part of this and to help us along the way. And then it took 12 volumes of lecture notes in computer science to publish all these papers. And this is not including the satellite events and publications. So that's what almost 900 papers give you. And these are the keywords of what were the papers accepted last year at MICCAI. These are the keywords of the papers submitted at MICCAI. So when I did a little subtraction, see, the really outstanding keywords last year were 3D, multimodal, diffusion, recognition, and understanding. So that was the theme of MICCAI 2024, and I can't wait to see what's coming at MICCAI 2025, because one thing is for sure, things are evolving fast at MICCAI, and themes are evolving fast too. So 2025 is coming to Daejeon in the Republic of Korea. Gina Park, Paulina Golland, and Jongkyo Kim are the general chairs, and many thanks to them for the fantastic organization that they're doing. You're in for a treat. In 2026, we're going to go to Abu Dhabi, and Mohammad Yaqub, Islam Rekik, and Chi Do are going to take the lead on that one. So while we don't have a program for 26 yet, in 2025, there are 40 workshops, 44 challenges, and 3 lighthouse challenges, and 11 tutorials. These are all fantastic events. And the theme of the main conference is Pan-Asian connection from concept to clinical. So you see what you should expect. Our keynote speakers are going to have diverse themes, including a radiologist, the outgoing chair of the Radiological Society of North America. Again, open science, clinici, talks, and over 900 posters in Daejeon. 3 Lighthouse challenges are going to take place at MICCAI 2025, and these are bigger in purpose, in data, in everything, in infrastructure. And all of these challenges provide a lot of free resources to everyone who wants to participate. And that our Lighthouse challenges, for the first time we're doing this in 25, are BRATS, the Brain Tumor Segmentation Challenge, CVS, which is Critical View of Safety Challenge, and Unicorn, which is a multimodal, including radiological, including histopathological benchmarking, and more. And you can find all of this information you see everywhere. There are websites, and this you can find either through the MICCAI conference or to the MICCAI Society if you don't catch them fast enough on the screen. We'll have awards and grants, and we have more and more awards for the participants to the conference, including our registration and tablet grants. RISE is offering grants. Mirasol, this is a new workshop at MICCAI, is offering grants. And I'm glad to say we got back our NIH registration grants. We're not sure about their future, but we got them funded again. And mentorship in support. And this I want to highlight here for this group more than anything else, because there are many activities that we're doing other than the career development program, where the MICCAI mentorship program takes place. We have the student board that is doing academia and industry networking events, the startup village. The competition for the startup village was online last week. I was one of the judges there, but the winners are going to come to the conference. The RISE-MICCAI mentorship program, which is much more scientific, focused on paper doing versus the career development at mentorship here. The Africa program continuing, and also the Young Researchers Excellence program organized around the conference. So we're looking for mentors always as well. And you can also, see them at MICCAI wearing this pin. Education webinars, I talked about this already. I'm going to wrap up by showing this. Resources for LMIC researchers. There are many other things that I'm not showing here, and this is not exhaustive. But RISE-MICCAI, Esther will take the microphone right after this and tell you about it. The Africa network, if you are based in Africa or with an interest in African research, please look at africa.org. And now Mirasol, which is the Medical Image Computing in Resource-Constrained Setting workshop and knowledge exchange, again, raising funding for participants from everywhere in the world to attend MICCAI and Mirasol. And of course, the Pan-Asian researchers, that's a focus for MICCAI 2025, given the location that we have. So join us, participate with us, because we want you to gain more knowledge through MICCAI. We want to offer mentorship or to learn from you, get you connected with others in the field, but you also get access to publication, to resources that the society is offering. And in the end, we're trying to build capacity with MICCAI all around the world. So with that, thank you very much. And Esther, I let you lead the conversation from here on. I'm definitely going to be at MICCAI if anybody wants to speak with me directly, but you can also contact me through the society channels for anything, questions that you may have, suggestions that you may have, because we want to learn from you also how we can help you best.
Thank you very much, Marius. This was an excellent overview of all the amazing work that MICCAI and the MICCAI Society is doing. I think you have created a lot of interest between the participants. So I think there's a common question that many people has been asking, and maybe you can either answer in written or if you prefer now, but it's about how could they join these special groups and what are the requirements? I guess it's quite broad, but yeah, if you don't mind giving some sense on that.
Right. So all the special groups have some information on the website of the society. The only requirement is that you are interested in the special group and you want to participate and work in any special group. So they're looking for active members. There are activities that the special interest groups are organizing, like workshops and challenges and webinars, and you can be part of this. And also you can attend their activities, right, to learn more about what's happening in that field. And I think importantly, get connected with other people that have the same connection. So these SIGs have emails. That's all it will take. Just send an email.
Thank you very much, Marius. It's wonderful. And yeah, I hope some of you are interested and want to join some of these special interest groups. As you saw, they do a lot of activities, and there's always help that and for you to contribute if you are interested. So yeah, let's thank again Marius for this wonderful presentation. And as he say, if there's any question, I'm sure he will be happy to reply via email.
I am. And just one thing that I wanted to add there. Esther and I met to the MICCAI mentorship program. And Antonio, who was my fellow, who is now co-chairing the MICCAI mentorship program, will tell you also about his experience there. Do connect with someone that you like, someone you admire, or just someone who you think would be helpful to you, right? Sometimes random connections are very useful too. So take advantage of all those resources. Thank you again.
Thank you very much. So yeah, I'm just going to spend the last 15 minutes a little bit talking about RISE. I think we have seen a little bit of the overview from Marius, but I want to give you some more direct explanation on how we're starting and what is our motivation, as well as some of the activities that we are organizing throughout the years. So hopefully you can see my screen. So a little bit of background. So how the RISE-MICCAI community started. So what we saw, and Marius also presented during the presentation, is that there was very little representation from underrepresented countries back in 2018, as well as prior MICCAI conference. So based on that, in 2020, the Islam, which was the former president of RISE, and it's today also here. So if there's any question, I'm sure she will be happy to also answer. She created, together with other members of the board, a special interest group, which was RISE, which stands for Reinforcing Inclusiveness and Diversity and Empowering MICCAI in Low to Middle Income Countries. And what is the objective, or which is the mission? So basically, what we would like to do is to strengthen the presence from minority researchers from LMIC, working in the area of medical image analysis, especially in the MICCAI community. And for that, we also want to foster cross collaboration. So it's not only about trying to bring them to the conference, but also try to see if it's possible to create collaborations that will go beyond the conference, that will also help to have a wider global outreach and impact. So for that, our goal is, as we're saying, to propel inclusivity, especially in LMIC countries, as well as empower researchers from these communities, and create a very strong network that will help us to connect people around the world. And I think many of us, you have already joined us, but if not, please scan this QR code and join our mailing list, and you will receive all the information about events that we organize. So with that, I want to present you the board member for this year, which has been created at the beginning of this year. As you see, we have many, and it has grown from the last board members, but I want to highlight a few roles especially. So I want to, first of all, give the thanks to David and Baro, which are the school coordinators and are the ones who has helped create all the summer school behind the scenes. So we should really thank them, because I think they have put together an excellent program. But also we have new things from the last year. So for instance, we have started a set of tutorials that I'm going to discuss more later, as well as some storytelling, where here what we want to do is try to bring people from different parts around the world and tell about their story. And this is going to go from very junior people and very senior. So the idea is to get to know them, as well as to get inspired by about their careers. And also now for a couple of years, we've been running a journal club, as Marius has mentioned, where we do regular meetings, where we present papers, and the idea is to create this friendly environment where people can come and discuss about a specific paper. So as mentioned, all the MICCAIs are located, so all the RISE-MICCAIs are located around the world, but specifically we are focusing on researchers from underrepresented countries that want to attend or has attended MICCAI. So here you can see a little bit of the numbers. So currently we have more than 1,500 members. And at the time that they join us, most of them, they never attend MICCAI. So that was something that in general are quite early career. And the idea is that they can learn, or they can take advantage of all the activities that we are organizing, as is mainly targeted for early career researchers. And also we have quite a good diversity between gender, men and women. And you can see here also some representation of where they come from, or ethnicity. It's still quite diverse, but we're still working to increase some of the numbers, some of the regions where we have less presence. And this is, for example, through this summer school where we have received a lot of people coming from the MENA countries. So I want to give you just a brief update of what are some of the activities that we have organized since MICCAI 2022. So the first summer school that we organized, in this case was a winter school, was held in November 27th, 25th to 27th in 2022. And there were 3 main days where they were giving a brief introduction of AI in medicine, as well as some key concepts about supervised image segmentation, as well as registration. Following by that, the following year, we organized a more specific summer school on the area of fairness as well as federated learning. And also for the first time, we held a Kaggle competition, which was a big success. It was very interesting to see how people around the world collaborate between them in this competition. So it was an excellent opportunity. And you can also, one good thing that we have is that all the material that we have done in the past is available through our GitHub. And also all these events has been endorsed by the MICCAI Society. And in the previous years, we had a diversity of attendees around all the world. And of course, all of this is run by volunteers. So it's people from the society, from the community that want to share their knowledge. So that's also something to keep in mind. If one day you would like to be part of the summer school, we are always looking for volunteers, either to present as well as to help with all the organization. As I mentioned before, we are also running some journal clubs where we have Algorithm and Toolkit. We are the coordinators. You might have seen emails from them presenting what is going to happen. They run bi-weekly. And since we started, we have 54 sessions, and we have many invited speakers from the community of MICCAI. And the idea, as mentioned before, is to have this platform where we discuss a paper at a time, and it's very interactive, it's very collaborative, and the idea is to just go in depth about a paper. And also sometimes we also give special sessions on how you, for instance, review a paper or how you write a paper. So it's not only the idea of trying to see how you disseminate a paper, but also how you can use some of this knowledge in order when you're going to be writing your own paper or when you're going to be reviewing them. And also, we always seek for more volunteers. So if you will have, for instance, have a paper and you would like to present it, please email us and you can then also be one of the presenters. And this is something new. Since this year, we also have all these sessions available online. So you can see any of our previous sessions available in YouTube. And also for the first time, we are now also having tutorials. So the idea of the tutorials is that once per month, we dive deep into into a specific topic, either in computer vision or medical image analysis. So this is something quite new. We have started in the spring this year, and we have for now only have 4 workshops, but the idea is that we are going to continue, and we have a lot of diversity of people joining. And also I think these sessions are super interesting as we can really go dive in one of the, for instance, in retina classification. And the idea is that once we have a good number of of these tutorials, we are going to try to create a book, trying to compile all this information that will be available online. This is still available online, and all the sessions has been recorded, so you can also go to see them. And if you join, as I mentioned before, our mailing list, you are going to receive invites to these new sessions when they're happening. But also outside, this was outside the MICCAI, but also every year in MICCAI, we have a lunch event where we have excellent keynote speakers talking a little bit about their history. So this was the first one that we had in 2022, where Professor Hodesh perhaps has given a little bit about his history. It was an amazing experience, an amazing talk. So if you are attending this year, MICCAI, I would really suggest you to come to this year talk, which is going to be Professor Tinashe, and I think you're going to be very impressed about his work, about his career. And these were the 2 keynote speakers that we have in MICCAI 2023. And during last year, also we have, as was mentioned before, a lunch event that was done by Professor Nasir Nabab. So that brings us to today, to the RISE Summer School 2025. And you can see here an overview of what is going to be happening throughout the different days. So as I mentioned, it's a 5-day event, which is going to be run 2 to 7 Central European time. And if I dive a little bit more into the different days, if you look at at today's session. The idea is, as we see here, we have first the presentation about MICCAI Society as well as the RISE, and then we are going to have a short break, and then we are going to go into a session about the new trends in AI, a small break, and then good practice in AI, and then the last session is going to be challenge and mentorship program, which there I see it's been quite some questions on the chat. We are going to try to go through all the different steps for applying for the mentorship, as well what it has to be happening, which are kind of the criteria that we're going to be taking, and we're going to reply any questions that you have. Also, as a novelty for the first time, although the event is 100% online, we also have some local hubs located around the world, as you can see here, where they have representatives where they are hosting, and people can come to see the presentations in live, and also some of them will have some further activities based on the local region where they are. So here you can see some of where are located these local hubs. And I want to take this opportunity to thank you very much, all the organizers and everyone who has contributed to create these local hubs, as I'm sure it's been a huge amount of work. And I think this is something amazing, as it's very great to not only have this online presence, but also if people can join together, as they think it's super enrichment and they can gain a lot from that. And we are sorry that we couldn't have a hub all around the world. Of course, this is something that we want to keep increasing throughout the year. So hopefully next year we can have more inclusion in different areas of the world. So about the mentorship program, I know, as mentioned, we are going to have more about it at the end of the today. But just to give you a brief idea, the idea is that we want to offer this mentorship for anyone who wants to contribute or is planning to attend MICCAI 2026, and for that trying to write a paper. So it's going to be open for everyone. However, there will be some selection criteria. So they will be given priority for those that who has never attended MICCAI. And that doesn't mean that you have to be having a PhD, doing a PhD. It doesn't matter the career of the stage. One of the criteria is that it's your first time attending MICCAI. And also for that, you will need to work in a challenge, which is going to be the LISA challenge that Marius has presented. And on Friday, we had a special session. In the case you didn't have time to come or it wasn't suitable for you, we put the recording online. And this today, at the end of the day, they're also going to come, the presenters, to give you a brief overview of the challenge. And the application will close at the end of this summer school. So if you haven't done that, please still go and try it. If you're interested, and especially after hearing what is about this mentorship, about the challenge, please submit your application to the mentorship program. And with that, I want to thank you everyone for coming today, and I want to give a special thanks to some people. So first of all, to all the RISE board members. As I mentioned, there have been 2 people who has highly contributed to the summer school, but everyone in the board has been very much involved, and all of them you're going to see them, some of them chairing the sessions in the future days in the summer school. Also, I want to thank the MICCAI 2026 local committee, as they have been super supportive with the summer school, and especially also helping to have local hubs on the MENA area. Of course, as mentioned before, I want to thank the local hub organizers. And this is fantastic to see all the work that they have put in here and how we have managed to secure all these hubs around the world. And last but not least, I want to thank the speakers that are going to come and present here in the summer school, as well as the MICCAI Society, and specifically Diane for all her support for the Zoom and all the organization logistics that goes behind of this. So with that, I'm going to stop sharing the screen, and I'm going to try to see if there's any question that you're having here. And also, sorry, I should have mentioned maybe as safekeeping, because we have grown a lot and we have a lot of people that want to be attending. We have moved from a standard Zoom to a webinar. So that means that if you have questions, please post them in the Q&A session. And then it's up to the speaker if they prefer them to reply via written, in oral, or can also help you to unmute, and then you can ask the question yourself. Yeah, regarding the Zoom, so every day there will be a different Zoom link, and this will be sent every day prior to in the morning. So you should receive them. If you not, please email me, myself, or anyone in the in the RISE board, and they can redirect you to the correct link. So every day will be a different link, and today this is going to be the link for throughout the day. Yeah, regarding the registration, we have sent an original registration that was closed 2 weeks ago, and then we have sent a confirmation one. If by anything you didn't get the confirmation email, because I think some of times these confirmation emails were going to the spam, please message me directly and I will add you into the next session and into the next emails to make sure that you receive every day the links for the sessions, as well as if there's any prerequisites. Some speakers have give us some information that you want to read maybe before the session. Yeah, I'm gonna post in the chat my email, so it will be better if you haven't received the confirmation, or if you have any further questions regarding the links, could you please email me directly, as by the end of the session maybe I don't get your emails in here. And I think there are a few more questions regarding the summer, the mentorship program, as well as the LISA challenge. I think it will be better to wait until the representatives from the challenge, as well as the representatives for the mentorship program comes. And then at the end of, by the end of the day, we hope that you have all the questions answers that you have regarding the mentorship program. I see one hand that has been raised. I don't know if it's easier for you to type the question in the chat, or would you prefer that I allow you to talk and ask you directly? Okay. Do you want to give us your question? Wafa? Or at least it's the name that is written in your Zoom link? Okay, if not, I think I'm going to pass to the next person who is asking. Wafa, it's your last opportunity if you want to ask something live. If not, please post your question in the Q&A tab. Amir, I think you also have your raised hand. Do you want to ask a question?
Yeah, Assalamu alaikum. I'm Amir Shahzad from GIK Institute. So I would like to ask that I mean this summer school is I mean you can say totally linked with medical side. I mean there is AI part, and then there is a medical part, and the publications that we will do, will it be linked with somewhat linked with medical side? Then we can publish that in MICCAI, or I mean we can choose any field and then we can publish that.
So the summer school itself will be a combination between technical skills as well as soft skills. When I mean technical, there will be talks, for example, about graphic and deep learning, which I think could be applied for medical, but as well as non-medical. And then some of the soft skills are more driven towards mechanical, but I think could be also be applied to other conferences, like how you write a paper, how do you review a paper. So that will be open, and it's up. You can use the skills either for MICCAI or somewhere else. However, for the mentorship program, this is going to be mainly focused for people who want to write their first paper to attend MICCAI 2026. I hope.
So it will be towards medical. I mean,
Yes, it will be the
okay.
mentorship program only. The rest
Okay.
of the summer school, it's really the knowledge of sharing out, for instance, new trends AI will be generic. Of course, there will be some implication in the medical image domain because this is the main goal of MICCAI, but it will be also, you can see the trends, what is happening around the AI community, of not only in the medical domain.
Okay, thank you.
Thank you. Yeah, regarding the recording and the materials, everything will be made available online via our website by the end of the summer school. Some of the sessions will not be recorded, and this is due to the speakers asking us not to record them, but the material will be all shared by the end of the sessions. Yes, so I think we are 5 minutes over. So now we are going to take a short break, and we are going to see you all in 25 minutes to start the new session at 3:30 Central European Time about new trends in AI. So thank you very much, everyone, and I hope to see you all in around 20 minutes.
All right. Hello, everyone. Welcome back to the summer school. It is my pleasure to introduce you our first speaker. He is Professor Xinyu Shao. He is an assistant professor of artificial intelligence in the Department of Radiology at the Weill Cornell Medicine of Cornell University. Professor Shao's research has focused on machine learning analysis of neuroimaging and neuropsychological data to explain brain behavior relationships and determine biomedical phenotypes of neurological diseases. His research received the K99 Pathway to Independence Award from the NIH, the Norsad Young Investigator Award from the BBRF, and the Innovator Grants Award and the Chairman's Award for Advancing Science from Stanford Psychiatry. Today, Professor Shao will share his insights on new trends in AI. And if you have any questions, please just type them in the Q&A box. Please join me in welcoming Professor Shao. And Professor Shao, the floor is yours.
Thank you, David, for the kind introduction. Is everybody seeing the correct screen I'm sharing?
Yes.
Okay, perfect. Okay, well, I'm super excited to be here today to talk about some of the new trends in AI, especially in my own research domain, which is neuroimaging based predictive modeling. And to begin with, I want to say something about myself and also a little bit fun geographic knowledge. I'm currently assistant professor in the Department of Radiology at Weill Cornell Medicine. This is basically the medical school of Cornell University, and it's actually located in the Upper East Side of Manhattan in New York City. And many of you might know the main campus of Cornell University, which is in Ithaca, Upper State, New York. But the medical unit is actually in Manhattan, New York City, and this is also the medical school and teaching hospital of New York Presbyterian Hospital. And actually, a lesser known third campus of Cornell is Cornell Tech, which is which was built less than 10 years ago, and it's a graduate school and research unit of Cornell University, located on Roosevelt Island also in New York City, and it has a lot of emphasis on multidisciplinary collaboration and partnership with industry. And we're bringing resources and faculty members across these three campuses of Cornell to build a strong program in AI for medical imaging research and deployment. And one of the reasons why I want to bring this up in the beginning of the talk is I think this type of co-design, co-location, and immersive multidisciplinary collaboration actually marks the trends of AI for healthcare and medicine nowadays. I think as AI researchers, we all agree that AI is developing at an extremely high speed. We're actually fortunate to be AI researchers in this era to be able to witness this revolution. It seems that each year there's a new concept in machine learning or AI that everybody's excited about and everybody wants to get their hands on. But today I'm talking in front of the MICCAI community, right? I think what makes us special, what differentiates us from other machine learning researchers is that we are actually the ones that direct how AI should progress to meet the needs of healthcare and medicine, and how to design AI with the purpose of better clinical outcome, right? In some sense, we are not observing or following the trends. We're actually the ones that define the trends in AI in medical imaging. And I believe it's our responsibility and the responsibility of this whole MICCAI community make sure that we take the full advantage of recent advancement of AI to make clinically relevant progress. I know many of us, including myself, are trained engineers or computer scientists, but I never see MICCAI as a pure computer science conference. I see MICCAI as the first, foremost place, the forefront of research where latest AI trends can be translated into clinical innovation, and I think that's our unique role and mission. And we also have to make sure that we're doing more than taking a training machine learning idea and see how it works out on some medical imaging data. A MICCAI paper is not necessarily our endpoint, and we always want to push AI towards a more clinically meaningful purpose and endpoint. So my own research is mainly about neuroimaging and neuroscience. So I would like to embed my view on the evolution of AI and how AI should further evolve into the context of neuroimaging research. And hopefully you'll find some of my thoughts relevant to your own field of interest. I would assume that not everyone here has worked with neuroimaging data. So I think the first thing I'm going to do is to give a little bit context what neuroimaging research is about. People actually have been long been interested in studying the human brain, right? This is the most complex, intricate organ in the human body. And the first non-invasive device, which can be considered as the precursor of modern neuroimaging, is this human circulation balance device, where a person is lying on this bed device, which is like a seesaw. And the idea is that when the person is performing a cognitive task, there will be a redistribution of blood flow towards the brain so that you observe a tilt of this seesaw. I mean, it's a cool idea back in the day, but but in no means I believe this actually would work in practice. But the thing is that we are pretty much doing the same thing as before, just more precisely in a more fancy machine. So instead of lying on the seesaw device, nowadays the person is lying on an MRI bed, when we're still measuring the blood flow in the brain. I guess in the MICCAI community, MRI is definitely one of the primary neuroimaging modalities of interest. But just to give you a broader picture, we now have many different ways to record the brain in terms of neuronal activity and brain structure and function. And just to give two exemplar MRI modalities that I'm going to mention in this talk, structural MRI, I guess, is probably the most frequently used MRI modality in MICCAI. And it provides a 3D visualization of the brain's anatomy so that we can measure the size of the shape or the integrity of different brain regions. And it is often used to detect tumor or lesion, to quantify traumatic brain injury or brain tissue loss in, for example, neurodegenerative diseases like Alzheimer's disease. And on the other hand, functional MRI is another frequently used MRI modality that can measure the brain's function. And so the idea is that a brain region, when it's active, causes more blood flow and consumes more oxygen. And so we can record the blood oxygen level, or so-called the BOLD signal, BOLD time series, over time at each walk. So in the end, you actually have a 4D image, 4D MRI scan, 3D space plus time to record the brain's functional activity. One thing I have to note is that the application of neuroimaging is quite diverse, right? So in a preclinical setting, neuroimaging is often used for driving neuroscientific discoveries to understand how our brain develops or ages in our lifespan, and to understand the neural mechanisms underlying different behaviors, cognitive capabilities, and brain disorders. And on the other hand, in hospitals or clinics, neuroimaging has already been used in many clinical workflows for example, tumor and lesion segmentation, cancer treatment planning, or aiding diagnosis. But depending on which specific application you're dealing with, the way AI machine learning is used actually differ in many ways. But in general, it has become increasingly clear that MICCAI is shifting from a pure method-centric community to a more balanced venue between methodological innovation and clinical relevance, right? So there's a growing emphasis on clinical impact of the work, human-in-the-loop AI development with clinician feedbacks, this co-design style with clinical experts, and these experts could be physicians in clinics or hospitals, or neuroscientists in a preclinical research setting. So In other words, we should really embrace the concept of what I call designing AI with clear purpose and think beyond just building a model. And my research is more leaning towards the left side. So in this session, I guess I'm going to share my review on how to best leverage machine learning to drive neuroimaging research for brain behavior mapping. So the idea of brain mapping, brain behavior mapping, or somebody call it brain-wide association studies, BWAS, is to build models that relate neuroimaging data and individuals' behaviors, cognitive capabilities, and disease labels so that we can find the neural underpinnings, the neural mechanisms of psychiatric diseases and behavior problems. And this will in turn help us to design new prevention, intervention, and treatment programs and help to build tools to predict risk for symptom onset or to predict treatment response, right? And to talk about the trends of AI in this field, I like to first go over what was the evolution of AI machine learning from past to now, so that in the end, hopefully we can talk about what is still missing in the MICCAI community for brain mapping research and what should be the trends, in my opinion. And again, we're not only going to motivate these trends from the machine learning perspective, but also from what critical clinical problems should be addressed. Okay. So the first question is, how was brain mapping research done traditionally, even before the machine learning era? In a very typical setting, after collecting the data from a population, let's say you have a group of healthy control participants and group of patients with a certain brain disorder, you first would have to extract a set of brain measurements from the MRI data of these participants. And these measurements could be, for example, a volume of a set of predefined brain regions or functional connectivity measures among a set of brain regions, based on your particular hypothesis of the study. But then for each measurement, the procedure is to perform a test, a statistical test, to see whether there's a distribution difference in that measurement between the controls and the disease population, right? And we repeat this test for every measurement. And in the end, we get a pattern that documents which brain regions show significant group differences. And that pattern essentially corresponds to the neuromarker that underlies the disease that can potentially be used for as treatment targets or risk factor targets, right? And even until today, this is still the most prevalent way in the literature. If you look at the neuroscience literature, and the reason why this practice is favorable is quite simple. This procedure is very easy to perform and it's easy to interpret the findings. But there are indeed two limitations here about this procedure. First of all, this is a population level inference. We're talking about the distribution of measurements across the whole population. You can never argue about the scenario of each single individual. And second, each of these tests is a univariate test, right? That is separately performed from all the other tests. So you can never model the interrelationship dependency across multiple brain regions. And these limitations actually drove the early promises of machine learning, right? So the narrative is that instead of doing this kind of repeated univariate tests, I can build this machine learning multivariate model that can take all the measurements from a single individual as the input and predict their diagnosis label to indicate which group this subject belongs to. And in this way, your model can capture the interdependency across brain regions, and we're making this subject level inference. And lastly, there's a further model interpretation step to see which specific regions are driving the classification process, and these regions are regarded as the pattern or neuromarkers of the disease. Just to give a more concrete example, let's say you want to work with a group of structural MRI scans. The first thing we do is to segment these each image into a fixed set of predefined brain regions. And for each region, we can extract many types of morphological features like volume of each region, right? The thickness of thickness of the cortex in each region, the curvature of the cortex, etc. Well, I guess I made this sound easy, but this is actually some serious business. This is something people, including our MICCAI community, have been working on trying to automate and perfect for several decades in terms of how to make the segmentation and feature extraction robust and fast. But the upshot is that once you extract these features from all the subjects, and if you know the diagnosis labels of these subjects, you can start building machine learning models. And for quite a while, at least when I was doing my PhD, these traditional machine learning models were still dealing with these tabular CSV features, CSV data, CSV files, instead of dealing with raw images. And I remember at that time, it was a major competition to see who can design the most effective regularization term in your linear regression model. And clearly, this is not something we're paying attention to nowadays. But this is pretty much a similar workflow for functional MRI analysis back in the day. So instead of extracting structural features, you can look at these voxel-wise or region-wise both signal time series, and you can correlate two time series from two different regions to quantify the functional connectivity strength between two regions to essentially indicate how similar these two regions activate or deactivate in a synchronized fashion over time. And again, you can turn these connectivity measures into a tabular file, a CSV file that traditional machine learning methods can process. And this is pretty much what people have been doing until 10 years ago, right? This is the procedure where the feature extraction step and machine learning predictive modeling were still two separate stages. And then comes the deep learning era, where the narrative is to omit the measurement, the feature extraction step, so that I don't have to have any prior assumptions in terms of which regions to extract measurements from and how those regions should be defined. Instead, I'm gonna make the model directly take the raw 3D volume metric, those voxel intensities as an input, and automatically decide what information should be extracted from the volumetric data. And since then, people have been trying to migrate successful deep learning models from computer vision to medical image computing. For example, my colleague back when I was in Stanford, Professor Ahsan Dali, created one of the first 3D convolutional neural networks for MRI-based diagnosis classification. And of course, the landscape of deep learning has changed drastically since then, and the latest advancement is pretty much about transformers or VIT vision transformers, where an image is divided into patches, and each patch is turned into a token that is fed into a multi-head self-attention module to extract an embedding of the image for the final classification task. We were actually one of the first that introduced this VIT architecture into 3D MRI-based predictive modeling. And other than structural image analysis, I guess deep learning has also revolutionized functional MRI analysis in pretty much the same similar fashion. I talk about the idea that we can use a functional connectivity matrix to record the functional relationship among different regions. But one thing to realize here is that this matrix, mathematically speaking, can be also represented by a graph structure where the nodes are just different brain regions, and the connectivity measures in this matrix define the edges among regions. And in this construction, we can apply again convolutional neural networks to fMRI data. It's just that now, instead of performing convolution in the image space where you have this fixed grid structure that underlie the image pixels, we are applying convolution in the graph space, which has a more flexible topological support of the data, of the functional features. And for example, one of the most distinct signature methods is called BrainGN, which was developed by Xiaoxiao Li, who is now an assistant professor at University of British Columbia. I guess this model is still the baseline method that appears in every paper on graph neural networks for functional MRI analysis. But of course, there are some other innovative architectures in this domain. Another line of thinking is that, I said that fMRI is essentially a 4D signal composed of 3D space and the time dimension. So one can actually define the graph structure not only in the spatial domain, but also in the temporal domain. So one trend nowadays that people start to explore more on the concept of 4D convolution, or what they call spatial temporal convolution, to analyze the 4D nature of the fMRI signal. And this is what we did in MICCAI 2020. I think it was one of the first to try this idea architecture for functional analysis. And of course, not surprisingly, the most recent trend focuses on integrating transformers to fMRI analysis. And one example here is just the boat transformer architecture by Badel et al. In Toga Trikura's group 2 years ago. Okay, so having briefly reviewed the development of AI for MRI-based predictive modeling, one thing we observed in this community is that there's definitely a very clear acceleration in new methodological innovation year after year. It's just absolutely impressive to see that how the best, most fancy model from 5 years ago became the worst baseline in your comparison table nowadays. The shift of technical trend is fast. The field is moving fast, and it's absolutely amazing to see. So for example, on the left, I have a list of training machine learning models in clinical imaging compiled by the Stanford HAI 2025 AI Index report. And most of these models are large-scale vision language models or foundation models, deep learning methods that are designed for large-scale image analysis. Meanwhile, I was invited to, just recently to write a review paper about the trend of machine learning in alcohol use disorder research. And by the way, alcohol use disorder is a major chronic neurological disease, that costs hundreds of billions of dollars in the United States alone, and much more worldwide. And neuroimaging data is the most frequently used data to understand the mechanism and the impact of alcohol misuse. So there's actually a significant increase in the use of machine learning for alcohol analysis. And after this scoping review, this is the list of top 10 most popular machine learning models used in the past decade for analyzing alcohol use disorder, and mostly on neuroimaging data. So, if you just started machine learning research, if you just started your PhD journey, I don't actually blame you for not knowing these methods. I think some of the methods here are even older than myself. And just in case you haven't found where deep learning is, this is here, right before K-nearest neighbor, arguably the most naive machine learning method you can think of. I was quite shocked by this statistics that I generated myself. I was shocked by this huge discrepancy between left and right, this huge gap between what is being developed in the machine learning community and what is being used in clinical research or neuroscience research. And since I've generated this figure, I've been keeping thinking about, as a machine learning researcher in the MICCAI community, what should I really do to reduce this gap? So to answer that, I'll share one of my early stories that kind of shaken my belief and broadened my view as a machine learning researcher. And this is when I first graduated my PhD from computer science and joined a medical school as a postdoc. I was given a task of using machine learning to find the effects of HIV infection on the central nervous system. Okay, so my first job was to classify MRIs of a group of HIV patients from the MRIs from a group of healthy controls. And I essentially spent my first 3 months of my postdoc in my office, trying everything I can, using all my brain cells to craft a model that can that push the accuracy, classification accuracy from under 70% to something like 70%, 75%. I don't exactly remember the number, but I was super excited about the progress. I went to my clinical collaborator, who's a neuropsychiatrist, and to show my results and said, look at these, improved figures and improved numbers. And the first response I got is, so what? Right? I mean, maybe not in these two exact words, but it was definitely a so what type of vibe that I was receiving. And the concern was essentially that why are you really showing me these accuracy numbers? I mean, I can simply do a blood test to diagnose HIV with a virtual 100% accuracy. Why would I need your MRI, super expensive MRI and MRI-based classification algorithm to tell me whether somebody has HIV or not? I mean, these accuracy scores don't mean nothing to me if they don't help us understand what was the effects of HIV on the human brain. And this is actually the same argument for many brain disorders where neuroimaging is not even part of the standard clinical workflow. And I guess that experience has really broadened my view on the role of neuroimaging in different types of clinical research. And the lesson I learned is that in that experience is that AI development, especially in AI, medical image computing, should really have a clear clinical or biomedical purpose, no matter whether it's for optimizing diagnosis precision or automating workflows, or it's for population health analytics or discovery-driven research. We should always try to have a bigger, broader picture and be aware of all the major gaps in the specific medical application you're working on, so that your AI machine learning development can actually make sense and can actually make a difference. Well, I guess as engineers and computer scientists, we're really good at designing loss functions or optimizing for accuracy or different metrics and conducting all sorts of comparison experiments. And this is indeed the core of our strengths, and we should be really proud of that. But meanwhile, as I said, to move the community forward, we should also care about the question of will it matter, beyond the methodological question of, can I build this? So we should build AI not just, not as a means to simply get a better metric or something, but with the purpose of pursuing clinical relevance or scientific relevance, and with improving healthcare as the end goal. So next, I guess I'm going to talk about 4 topics in my research domain that I would like to see more discussion on. In fact, these topics are not isolated but intertwined together, which I will hopefully make clear. And later, as you can see, these topics are not, did not originate from a machine learning methodological perspective, and they are actually roadblocks in clinical research, in brain mapping research that needs machine learning, machine learning tackling. Okay. So the first major problem that I want to see more, effort or attention on is the problem of generalizability or reproducibility. Okay. In fact, I think one of the 4 primary aims of the National Institutes of Health of the United States, the NIH, proposed by our new director, Dr. Bhattacharya, is to establish reproducibility of medical findings. And clearly, reproducibility has been a major issue in neuroscience, especially in neuroimaging research for quite a while. And one conception about neuroimaging studies is that they are often underpowered due to the limited sample sizes. And nowadays, I know we're always talking about big data analysis, but one thing we have to realize here is that neuroimaging, or big data in neuroimaging, is not necessarily big enough. I mean, even with the largest UK Bell Bank or the ABCD study, you have at most tens of thousands of scans. I mean, those numbers are nowhere near being big enough in a machine learning standard, right? And those data are primarily about healthy subjects, and the problem's even worse if you look at, you want to analyze people with a specific disease. And just to give you an idea, to calibrate what happens in most brain mapping studies in the literature, a typical R1 study in the United States, R1 is the most common type of research grant awarded by NIH. It typically only can cover the cost of recruiting 100 participants. And that factor alone can limit the application of machine learning in many clinical studies. And for example, in my field of brain behavior mapping, a splashy paper from a few years ago suggested that a reproducible analysis requires at least thousands of samples, which this paper triggered quite a few discussions at that time. One approach that I think that is increasingly being adopted in MICCAI that can potentially advance this problem is self-supervised learning. And the idea is that you can essentially pre-train a model, usually called an encoder. You can pre-train this encoder on massive data, and the training data can be unlabeled, so that you can essentially pull together all the MRIs you can find on the market from hospitals, from cohort studies, and they come from diverse population. They don't have to have the same disease. It doesn't have to have any label on it. It's just MRI volumetric data themselves. And based on this larger training data, you can train an encoder that turns an MRI into a meaningful lower dimensional representation. Somebody would call it an embedding. And the thing is that once you pre-train this model, you can apply it to a specific clinical cohort of interest and perform some downstream classification, which now should have labeled information, diagnosis labels, but this specific cohort can have smaller sample sizes. And our lab has made efforts along this self-supervised learning direction in two scenarios. And the first direction is very similar to the idea of contrastive learning, where the goal of this pre-training is about finding a latent space such that samples with similar semantic meaning should live closer in the space, whereas samples of different semantic meanings should live farther apart. And we leverage this idea, this notion, in the setting of longitudinal neuroimaging studies. And we first developed this idea around 2021. The latest effort along this line of research, spearheaded by my colleague Hee-Jun Kim at Cornell, was recently published at PNAS. And the idea is that in longitudinal studies, each participant is scanned repeatedly at multiple time points, right? So in the latent space, the embeddings of these multiple MRIs from the same individual would form a temporal trajectory. And this trajectory, in principle, should reflect the aging pattern of that individual, right? Because it is over time within the same individual. And the rationale of our model is to learn an encoder such that all individual trajectories should coherently progress, should coherently align with this general aging direction in the latent space. And this is the only regularization that guides the learning of this encoder, essentially to form coherent aging trajectories in the latent space from the population, right? And it turns out that this regularization itself is powerful enough to give you very meaningful latent representations. And I just want to tell you what the model can do in the end. So basically, what you only need to do is to shovel all these longitudinal images, volumetric data, into the model with nothing else. You don't need to tell the model their actual chronological age. You don't need to provide any label information, any metadata. The model would just chew on these images and automatically figure out which brain is older and which brain is younger, and can then generate this unbiased estimate of brain age for these images, and these are unseen images in the test site. And you'll be surprised to know that for these images that I show here, they are all from 80 years old in chronological age. Yet they have very distinct brain age, brain appearances. And our model essentially can figure this out without knowing anything about the chronological ground truth age in the training data. And this self-supervised learning, we believe is quite powerful in generating these kind of embeddings that contain rich information about brain aging, which are also quite, which is also quite useful for many downstream tasks, disease classification tasks that involve abnormal brain aging patterns. Okay. And the second strategy of self-supervised training we've been exploring is based on the concept of masked autoencoders, which basically aims to train a model that can reconstruct missing patches of an image. We apply the same idea to analyze functional connectivity matrices, where we randomly throw out parts of the functional connectivity matrix and then train this transformer-based encoder decode architecture to get embeddings that can reconstruct the full original matrix. And we're not the only one that is exploring this idea, and there are several variants in terms of how to mask out parts of the MRI data, how to reconstruct the original data based on masked autoencoder strategies. But the upshot is that based on these pre-training strategies, people have shown that the embeddings from these self-supervised learning models are helpful for a wider variety of downstream classification, disease classification. I guess one thing, if you look at this table, one thing you will notice is that the range of accuracy, if you look at these numbers, the values of these numbers, the range of accuracy across these 8 prediction tasks varies drastically, right? And that led to one observation that the predictive power of many brain disorders, especially for those mental health disorders, I would say it's not very machine learning friendly. So sometimes I say that if you hit the jackpot if you get something around 70% accuracy for a certain type of psychiatric disorder classification. And if you look at all the predictive analysis in general medical imaging based applications, it has an upper 90% accuracy, right? So essentially, behavior traits or mental health problems are among the least predictive phenotypes. Well, you can argue that, well, you talk about self-supervised learning to involve more training samples. So is it really is this a matter of sample size? Is that because you don't have enough samples with a certain mental health disorder in your training data? Wouldn't you just increase your data sample size to resolve this problem? And unfortunately, it doesn't work like that in reality. Well, I guess for us, as machine learning researchers, we all buy in the story of the scaling law, where we have better prediction accuracy with more samples. But in brain behavior association studies, you got less accuracy actually with more samples. And this is something repeatedly validated multiple times in different review papers. And for example, in the largest neuroimaging data sets like UK Biobank or ABCD, we often got brain behavior correlation of 0.1 or under. So these are extremely small effect sizes that we can find. The question is why is this contradiction? Why is this negative correlation between accuracy and sample size? Well, here I'm going to mention the second challenge to answer that question that we should, the second challenge that we should pay more attention to, which is population heterogeneity. Okay, so in an ideal world, we assume that the data forms 2 clearly separate clusters so that our machine learning model can find that classification boundary. But in reality, you might have very different scenarios where, for example, the disease population may have multiple subtypes, and the disease might lie in the same continuum with healthy controls, or there might be comorbidity of multiple diseases that are lumped into a single clinical cohort. The thing is that if you look at those small scale studies, they're typically collected within a short time period, and they are typically from a single hospital. They might be from the same community with they share a similar socioeconomic or environmental background. So it's more of a homogeneous group where you can expect that the brain behavior relationships is more uniform. But as you start to collect bigger data sets, the population is going to be more diverse, and more factors will start to influence the brain behavior relationships in a non-universal way. So it gets harder to find the correct or universal model that can fit to everybody, right? And the thing is that these external factors, confounders or moderators, they can modulate your brain behavior relationship in different ways, and they totally change the predictive power of the model. So it actually requires us to specifically design models to accommodate these distortions. The for example that we're working on is on confounders or variables that can influence both the input and output variables of your machine learning model. And confounders can heavily distort brain behavior relationships. So for example, if there are pronounced aging effect or sex differences in the brain, and meanwhile, some diseases are, let's say, female-oriented or male-oriented, or more prevalent in a certain age population, if you do not control for those confounders, the learned model might be just a sex classifier or an age predictor, rather than predicting disease diagnosis. So when you have these confounders, you can imagine that it's going to be very hard to build an accurate and generalizable model. In fact, the topic of this confounder-free learning or unbiased learning of fire or environment learning, depending on the context, has been widely explored in recent years in MICCAI. And particularly, this slide shows one of the early works that we did around 2019 or 2020. At that time, it was pretty much the first few studies that look at these confounder effects in medical imaging based applications, deep learning applications. And at that time, adversarial learning was still considered state of the art, was still the trend. So we designed this adversarial learning strategy where we forced the predictive model to be only predictive of the target diagnosis variable, but unpredictive of the confounding variables. And in that way, it forces the prediction not biased by confounders. And the latest advancement of this line of research essentially make this framework adaptable to transformers and in a continual learning setup. Okay, so other than confounders that can influence brain behavior relationships, another important statistical relationship that has not been frequently looked at, but should receive equal attention, if not more attention, is the moderation effects, or the effects created by moderators, those variables that can modulate the mapping function between brain and behavior variables. So moderation is quite different from confounding. It actually creates multiple brain behavior pathways. So for example, a simple example would be for certain diseases, males might have a unique mechanism for females that is totally different from males. And so that if you have a perfect model for males, by construction, it won't work well for females. And that poses a question to the current machine learning design, where oftentimes we aim to build a single universal model that works for the whole population. And it really questions this existing paradigm. In fact, there's a systematic study by Green, Dustin, and Todd at Yale, where they look at which specific population, on which specific subpopulation the model would frequently fail to predict. And they found out that the predictive power of a model would systematically correlate with certain social demographic factors. And this is a phenomenon that can be replicated across many, many data sets. And what it essentially means is that it's going to be very challenging to have a universal single model that can work well for all subpopulations. And the failure of this one model fits all paradigm suggests that we might need to relook at how we should design predictive modeling for the heterogeneous population. And it means that we might have to pay more attention to subpopulation specific models or build models to help us explicitly understand how external factors can moderate the predictive pathway from brain to behavior, right? So, for example, in our recent work, we conducted this sex-specific analysis and found that the functional connectivity, certain functional, the association between functional connectivity and certain behavior is only present in one subpopulation rather than the others. For example, the connectivity between sensory motor and salience network is very significant. Its correlation with thought and attention problems is very significant in males, but not in females. And the same thing for adverse childhood experiences. Certain brain behavior correlation is only present among adolescents with severe adverse childhood experiences, but not the rest. And in this another work, we also aim to use a data-driven framework to uncover which subjects are going to be more predictable than others and how this predictability varies with external factors. So we build this factor graph where we model the relationship between individuals based on how similar they are in their metadata, in their external factor values. And we estimate these subject-specific weights, which essentially indicate which subjects are more predictable by the model. So essentially, this is a data-driven way to say, I don't want to enforce the model to work well for everyone, but I'm going to find out in which subpopulation I can learn a better, more accurate brain behavior mapping. Okay, so other than social, demographic, and environmental factors, another major factor that can lead to substantial population heterogeneity is disease comorbidity, especially in psychiatric disorders where individuals with the same disorder can have vastly different sets of symptoms. For example, in depression, one can have trouble falling to sleep and get depression, and another person can, have trouble getting out of bed and still called a depressive a person. So these two people have the same disorder, but they represent totally opposite symptom and likely totally opposite neurobiological mechanism. So can you imagine that when you have this diagnosis labels that are diffuse and fluid, the group difference between populations, cohorts will get diminished, and there's no way you can build accurate, credible, and generalizable machine learning models for this type of data. So comorbidity is not actually limited to mental health symptoms. It can also be multi-organ disease. So for example, the alcohol addiction problem that I mentioned earlier, it affects virtually every organ system in the body. So what I think the field can benefit more is more efforts on whole body MRI, multi-organ brain body research. And this might require multimodal data analysis to support richer phenotyping linked to diverse disease profiles. So for example, this recent work by Jiang et al. In Hong Tu-Zhu's group at UNC, they built this workflow to integrate multimodal data from the UK Biobank, including demographics, lifestyle, specimen, genetics or imaging to jointly explore the risks and effects of interdisease correlations and multimorbidity mechanisms, right? So speaking of this multimodal analysis, I'm going to spend the last few slides of this talk to mention the challenge in multimodal neuroimaging research, that how to really disentangle the unique role of neuroimaging data from other data modalities or other data sources. And to showcase this challenge, I have a figure from this paper from last year's American Journals of Psychiatry by Green and Squaglia in South Carolina, which they are doing a predictive framework to forecast which adolescents would initiate substance use. And this is a really beautiful study, nicely executed. But one thing is that they show that neuroimaging data is basically the least important features data across all factors in predicting the outcome. Instead of using neuroimaging, the model would use culture and environment, demographics, or physical health, all the other non-imaging data to perform the prediction, but not neuroimaging. And the question is why neuroimaging is so not important, although we know that substance use disorder is a major neurological disorder. And what happens there is what I believe that neuroimaging, first of all, has a very small effect size on the outcome. And second of all, it's collinear with other non-imaging measures. So in the end, the signal is just probably going to be overwhelmed by some surrogate predictors. So this to me is a really big shame because arguably neuroimaging is the most expensive part of these studies. So ideally, we shouldn't stop with the model that says neuroimaging is not important. And to solve this problem, I think we really need to think about the relationship between different types of predictors. As I show here as a conceptual figure, these different type of factors, they actually form a complex causal graph where there's an intricate dependency between brain and non-brain data. But when we build machine learning models, oftentimes we're turning this hierarchical complex graph into a simple flat concatenation, and all these factors are regarded as independent, separate, and they're shoveled into this big blender machine learning model. And the result of this practice is that it creates a huge amount of redundancy and collinearity, which obscures the value of neuroimaging and leads the model to essentially prioritize those variables with strong yet superficial correlations. So I think it's just very critical for us to think about, to put more efforts on modeling the correct causal relationships among different types of predictors. And one example approach we have been trying is to first find association between imaging and non-imaging predictors and use those brain behavior coupling, brain, non-brain coupled variables to predict the final outcome. Now, of course, this is not something, this is not causal modeling, and because in observational studies, you can never truly investigate causal relationships, but still this approach, we believe, can generate clear variable dependency mimicking the causal graphs here. So for example, in this final example I'm going to give, we develop a new type of canonical correlation analysis where we use graph networks to automatically extract brain networks and correlate those networks with non-imaging cognitive test scores. We're able to extract a set of brain behavior coupled variables, and we can use those variables to perform a classification between healthy controls and patients with alcohol use disorders, and this is all done in an end-to-end fashion. And what is more interesting in this model is that the interpretation is no longer saying which single predictor is important for classification, but it actually show that functional networks can mediate the relationship between the diagnosis label and other non-imaging cognitive factors. So overall, I think this is a very cool example to show that how can we build accurate brain-based prediction while providing a more concrete mechanistic understanding of the role of neuroimaging in the pathway between mental health outcomes and other behavior measures, behavior variables. Okay, so I have talked about these four concepts in brain mapping research that I feel like should receive more attention and should be more trendy, if you will. And as you can see, none of these topics, strictly speaking, are from machine learning standpoints, but they are actually major obstacles that can slow down brain behavior research. And they do require new, innovative, laser-focused machine learning innovation to tackle. And my point here is that to move the field forward, we really need to have the mindset of designing AI with purpose, no matter whether it's for knowledge discovery, it's for model evaluation or model development. And regardless what medical application we're working on, we really need to identify clear healthcare needs and think about what are the major knowledge gaps and think about how machine learning can close that gap. And in that way, we can, become responsible and impactful AI researchers and effectively advance the field of MICCAI, the whole MICCAI society forward. And with this submission, I guess I'll end this talk. Of course, all the works that I mentioned here are fantastic teamworks, and I'm only listing those who contributed the most to these works. And thank you for the attention. I guess there are questions I haven't really tracked along the talk that I can look at now.
Yes, thank you so much, Professor Shao. We have a very lively Q&A box. Thank you for your insightful keynote. And I will just start and go for a few as we have 5 minutes. So there is one regarding the transition or production level deployment on the clinical workflow. So it's have any of the machine learning approaches been applied in real clinical settings at hospital for patient diagnostics outside of the research scope? And if not, could you elaborate why that is?
Definitely, there are a lot of machine learning techniques that are already actively used in clinics. I mean, the FDA already approved. I mean, there are more than 1,000 AI tools that are already cleared by FDA, right? But there's still a discrepancy. If you look at those 1,000 FDA cleared tools, not all of them are actually being used. I mean, I just talked to some of my clinical collaborators in the radiology department. They purchased some commercialized AI tools and had some trials, but then eventually was abandoned. It was not used. They go back to their old practice. So the challenge is that the transferability of those tools is questionable. So again, it's just about population heterogeneity. Those tools might be validated really well on certain population, but if they're transferred to a different hospital, you will see a gap how it didn't work as well as promised. But meanwhile, I also have to say that each hospital essentially would use their in-house developed tools, without FDA clearance. So you have these two tracks of usage. You have these, FDA validated tools that are not being used, and you have these used tools in-house that are not being massively validated. So I guess from the clinical deployment side, there should be more efforts in the MICCAI community that focus on how to evaluate the deployment of AI tools in clinical settings to bridge this gap. I think that answers the question.
Yes, there is another question regarding lack of data. So machine learning models tend to only do well in the case where there is an excessive amount of data. What is the approach that the researchers are taking otherwise? And maybe I could couple it with another one. Could you comment on data augmentation techniques for scarce clinical data? Because such algorithms and techniques can be useful for clinical data trials where participation is very limited.
Yeah, that's a good question. I think it's a very critical question that I don't have a clear answer for, especially for the data augmentation for specific sparse clinical populations. I know people are working on, a lot of people have this idea of applying generative modeling, all these new generative techniques use it for data augmentation in the hope that they can, increase the size of these clinical cohorts. But we do have to consider what is the endpoint of this analysis. I mean, if you have a chance of modeling the underlying distribution of your data in your generative modeling, why wouldn't you just directly use that knowledge to perform some downstream, the final classification task, right? So why do you really need to have a data augmentation step in between? So it's always a head scratcher for me. I cannot wrap my head around that idea, and that's based on assumption that the generative modeling technique would work for these sparse populations. But in reality, what I believe is that it might not work that well if you have just a couple hundred samples and you want to see the distribution shift in the brain space. In my research in the brain space based on generative modeling, it's not quite promising, at least at that point. So we do have to think about turnaround, alternative ways to deal with these sparse cohorts. I think maybe one trend is just to formulate more from the outlier detection perspective, abnormality detection perspective, rather than this pre-training versus downstream classification. And that might have a better chance, but still this is an active research topic, I think.
All right, and maybe one last question. This is about resource constraints. So Anais asked, which approach would you recommend for image segmentation when working with limited local resources? Vision transformers or the classical units?
I myself, I'm not actually working on segmentation, but my perception about this one is that for segmentation, essentially the latest technology, the latest models have clear edge over traditional models, because this is the task where you have better crystal clear metric to optimize. I mean, you have all these many benchmark data sets and allow you to very stringently compare the accuracy of different segmentation models. So relatively speaking, in this domain, usually the latest models have better accuracy and precision for this type of tasks. But in a resource constraint scenario, well, this is something, well, it depends on really what you're looking for. I mean, there are ways that can bypass the resources, limited resources. You can take all these pre-trained models, foundation models, right? And you can do model distillation to have smaller size models, and you can have active learning that requires you to have smaller sample sizes. And these are there are abundant, plenty methodological bypass that allow you to work with limited resources.
All right, thank you so much. Professor Shao would just go through the rest of the open questions. And now we will move on to the break. So I thank you again for your insightful presentation, Professor Shao. And we see each other in 30 minutes or 28 minutes.
Thank you all. Thank you all for the attention. All right.
All right, and so it is my great pleasure to present to you our next speaker. She is Wonder Woman. I'm talking about Professor Lena Meyer-Hein. She is the head division Intelligent Medical Systems and the German Cancer Research Center. And she serves as the managing director of the DK FZ Data Science and Digital Oncology cross-topic program. She's also a fellow of the MICCAI Society and of the European Laboratory for Learning and Intelligence Systems, ELIS. She's also the president of the MICCAI Special Interest Groups on Challenges and chair of the International Surgical Data Science Initiative. Her research focuses on machine learning-based biomedical imaging analysis and specific focus on surgical data science, computational biophotonics, and validation of machine learning algorithms. So today, Professor Meyer-Hein will share her insights on good practices in AI. So likewise, if you have any questions, please type them in the Q&A box and we will do them at the very end. So please join me in welcoming Professor Lena Meyer-Hein. Professor Hein, the floor is yours.
Thank you so much for this very nice introduction. My pleasure to be here, and congrats on this event. I see you have a lot of registered people. That's great. Okay, yeah, I was asked to give a talk on the topic of best practices. I'm not sure how qualified I am, but I can definitely talk about failures that I have encountered and maybe things or ways to address them. You should now hopefully be able to see my screen, the failing forward
Yes.
thinking. Okay, perfect. All right, so let's get started. So I don't know if you've seen this paper before, but when it came out, I was super excited. So don't worry about the details, but what you can see. Wait a minute, let me get my laser pointer. So you see here basically a lot of publications that were released when COVID basically happened, and in color coded you see the data sets that were used to diagnose COVID. And when you look a little bit closer, then you see that a lot of people used the yellow and the blue data set of pneumonia control group and then the COVID patients. And if you look even closer, then you see that the first data set, the yellow one, comprises only children, and the blue one comprises only adults. So in other words, all the AI had to do basically was to distinguish children from adults. Another example, this is now about brain tumor annotation, and what you see is basically the reference on the left, the radiology annotation, and then the prediction of the algorithm on the right. And you see in this specific slice of the patient, there's a very, very good agreement. But if you scroll a little bit, then you see that actually the algorithm has missed right here a small metastasis. And yeah, my husband's group actually analyzed this at scale, and they found that due to this behavior, actually instance progress, so disease progression, was actually missed in about 1/3 of the cases that they analyzed. And this was despite the fact that this very algorithm that you see here basically won international challenges. It was basically regarded as the go-to algorithm that could in practice replace a radiologist. So in this specific case, what happened is I think we have a problem with the phrasing of the whole problem. So in the particular case, we phrased the problem as a segmentation problem, which means we basically count pixels, right? So the dice essentially counts pixels, which means that if you have a huge lesion, which is often the case, and then a very, very small one, then the small one is basically noise in your validation. And by the way, not only the validation, so ideally you align the loss in your networks in line with the metrics that you use, and then also the algorithms were basically trained to ignore such small lesions. So we should have, from the beginning, phrased this problem as an object detection or instance segmentation problem, which we haven't, or which has not been done in the community. And I'm showing this example and the previous one really for underlying, I think, a meta problem that we have in the community. We spend a lot of time on, designing network architectures, spending time thinking how we should optimize, but I think sometimes we're missing out on the what do you actually want to optimize. And this is something that, I've personally actually spent a lot of time in, among others, in the special interest group for challenges. In the special interest group, I have the pleasure of working with a great team of people and also other societies, institutions beyond MICCAI. And we basically look into the topic of validation of benchmarking quite holistically, and I will basically present you some pitfalls and solutions on this today. And it all started actually pretty much 10 years ago. I remember this very well, when challenges became more popular. So as you know, challenges can give a lot of fame to people, to algorithms. There can be a lot of prize money. And I remember talking to Matthias at that time, 10 years ago, Matthias Eisenmann. I said, okay, are we sure that the way we benchmark now, the winner is actually really the best? Should we have I said, quick look into this? So the quick look turned out to be, I think, 3 years. But in the end, we recruited a large team, basically a large consortium of people who had organized challenges. And our first work was basically analyzing that challenge data to draw some conclusions. And I want to basically go through several steps that are relevant in the context of benchmarking, even algorithm development, as you see later. Okay, so let's start with data quantity. So one of the things back in the days, and I will come to much more recent work in this talk as well, of course. So what you see here is an analysis of how stable winners of competitions were at that time. And to look into this, we did bootstrapping. So I want to recap bootstrapping because I think it's a very important technique you should know. So bootstrapping, you have, for example, n test cases. You can imagine these test cases to be images, for example, and then you sample from them repeatedly and with putting back, basically with putting samples back. And then in this specific case, we would basically compute the challenge ranking for each time we draw. And then we do some statistics about who wins the competition. And as you see in the figure, hopefully, then only a very small fraction of challenges, those here, actually remain stable under these challenges, meaning in 100% of the bootstrap samples, they actually stayed the winner. And then, you see the results on average are actually quite unstable. And now you could say, of course, but this is because at that time we had little data. So we, of course, also computed statistics on the data. At that time, we were talking about 200 training images, 230, 380 test images. But to be honest, I think we're now running actually into a similar problem now that we validate foundation models. It may be true that now we have more data to train and test, let's say, our downstream applications on. But I think that now that we talk about foundation models, what used to be the test images is now the task that we basically test the fundamental capabilities on. So now I will always put this new sign here if I talk about the new era of foundation models, something new, a new challenge that we encounter. And so if you think about it, we have, for example, 20,000 disorders in radiology. And now think about how many tasks the so-called foundation models are currently tested on. I can tell you in the field of surgical foundation model validation, we talk about less than 10. So then think about the problems that we may actually have in terms of numbers, thinking back of the bootstrapping example I showed you. Then, of course, super important, maybe sometimes I think is the most underestimated aspects in the whole design, the data splitting. There has been a great paper on actually leakage. And I think, speaking to a lot of researchers in, for example, thesis advisory committees or also to students, I think this whole aspect of data splitting is really, or the importance is not so clear for many people. So of course people know that, you know, the training data and the test data should be disjunct. But then what is maybe not so obvious is how you actually do your model development. Because if you only reserve data for training, hyperparameter tuning, and testing, then often you will end up doing actually model overfitting, because you will run the same pipeline with many different models or configurations of models. So effectively, you still basically overfit to your data, because you don't only look at your test data once. So this is why, for example, in my lab, what we have, and it's in terms of implementation, it's not actually that straightforward because data is sparse, but we always keep what we call an untouched test set. So this data set is only used once. Everything is completed. We will do this one run. And of course it's risky, right? Because if your hypothesis is not confirmed, you have a problem. On the other hand, if you did your job right from the beginning, then the likelihood that your method generalizes is actually higher. And yeah, and now in foundation models, the new challenge is, of course, the leakage, because you have no idea what models, the pre-trained models, have been tested on in many cases. So whatever data is already public, you may have the problem that that is basically it's contaminated data because has been used in pre-training of some models. And I mean, some cases may be obvious, but others are not. So for example, I just talked to somebody whose name I will not mention, but he told me that they had reserved a great data set that they never want to release. So they have something independent test set to challenge results, to test ideas. And then they learned that the hospital had actually sold it to a big tech company, that same data set. So maybe now, yeah, again, the test data is contaminated. Yeah, there's things that you can do. For example, there has been a iClear oral this year, also a spotlight on a live bench where basically you on the fly add test data such that you avoid leakage. Okay, next related topic would be data shifts. I'm not sure if you followed this whole story, but I remember that this Google algorithm or deep learning algorithm, sorry, was in the media for detecting a diabetic eye disease or diagnosing it, and then a few years later it was in the media again because it actually failed basically in clinical practice. What was the reason? Well, I mean, the information may not be entirely complete, but I think one thing that was underestimated is also the compliance, the human factor issues. So if you tell, this is exactly from my experience as well, if you tell clinicians, okay, for example, please acquire this image in a certain distance or under these conditions, they will try to do it, but maybe just approximately, so you're easily out of distribution. And yeah, issues such as these can be really a problem. And despite all the foundation models, if you look into the literature, this is again a recent paper on this topic, you see that yeah, models may excel in benchmarks, they may perform really, really good, but when they're deployed or tested in challenging conditions, they fail. And sadly, this is maybe interesting in the context of the RISE, there's also actually an increasing disparity shown in this specific work. So what's new? What's new is that all of a sudden we have new shifts. For example, in my experiments, and this is also well documented in the literature, the models can perform completely differently depending on how you prompt them. So we also have the prompt shift, maybe even unintended use of the models, and all these new shifts that we never had to talk about before. Yeah, next topic, metrics. I've given you one example in the context of metrics where we had a problem, the DICE metric in the context of brain tumor annotation, if you remember. Now I want to show you another example from classification, actually. And here specifically, I want to talk about prevalence shift, meaning that class distributions change. So why would class distributions change? Well, one, often people train, for example, in a balanced manner, 50-50. If you let's talk about binary case for now, but basically everything that I say generalizes also to multi-class. So you train 50-50, but then in reality, your positive classes have a very, very small prevalence. Or I'm sure you've seen this in COVID. I remember I had a hard time explaining to my family that whether or not they probably have COVID, given they have a positive test, depends highly on the actual prevalence currently in the population. So there are prevalence shifts due to a variety of factors, and we know that certain metrics are prevalence dependent, so they depend on the prevalence, the class frequencies, and some are not. So let's look at an example here. At COVID diagnosis, you see the confusion matrix, some popular scores that you can derive from them, both are actually prevalence dependent. And now we change, we train in a balanced sampling setting, and now we deploy the algorithm in a low prevalence setting, which is actually likely to occur. And you see that in this case, the metric values change radically, although we haven't changed the algorithm, right? So the intrinsic properties remain the same. And I think this is very problematic, especially given the fact that often, you read something in papers like, well, we have an accuracy of XYZ, and previous people reported an accuracy of whatever else. You cannot compare prevalence dependent metric values, actually, when you have completely different data sets. That's very important to note. Okay, so what can you do? Just to give you an example, yeah, I'm sad that we cannot do this a bit more interactive, because this is a webinar, so now I just have to talk and hope that you're listening. So I would have liked to ask you if you have heard of expected cost as a metric before. Well, I'm sure you've heard of accuracy and error rate. So accuracy is just 1 minus error rate. And you can actually write this down a little bit differently, the same term, the error rate, in a way that it is a function of the prevalences of the positive and negative class. Again, prevalence meaning class frequencies, basically. And then if you rephrase a little bit more, you arrive at a formula where if you set the cost to 0 and 1, 0 for same class, 1 otherwise, you actually, you get basically this formula for the error rate. And now, why is this so interesting? It's interesting because what we can do now is we can replace whatever prevalence we see in our data set with the estimated real-world prevalence to basically adjust for the fact that metrics can be prevalence dependent. And if we do this in this particular case, we basically get comparable metric values. Okay, so this was an example on that it's important to think about which metrics you choose. Now it's also important to configure your metrics properly. So we'll give you another example for this one. So maybe some of you are working in detection. So if you're working on detection, and I'm making this short, I know if you're not working on detection, it may be hard to follow, but you will still get the gist. So if you're working on detection, you have one important design choice, which is when do you count something as a hit? So if you have a reference annotation and your prediction, is it a hit if you have full overlap, or is 1 pixel overlap sufficient? This is something that you have to decide. Typically, you would basically give a threshold, an IOU threshold, a intersection of a union threshold. And because it's hard to determine the threshold and metric values are quite dependent on this, what is often done is you basically would average over a whole range of values. So which range would you choose? Typically, the machine learning community chooses, for example, the range that you see depicted here from 0.5 to 0.95. But we have actually seen that if you ask clinicians, and this is data from 3 different hospitals actually, they, in this specific application, and we're coming from a specific application, right? They completely disagree with this, generic computer vision threshold. They would prefer a much more relaxed threshold because all they care about is that the position of the polyp is roughly provided. They don't need an exact delineation. And here you see basically a big difference between the clinician's preference, which I think is in this case what matters, and what people typically do. Okay, so in a large consortium, and this is an initiative actually of the MICCAI SIG, the MONAI benchmarking community, and also the Helmholtz imaging, we have looked into such problems. I cannot mention all the people. You see the co-authors here, but there's been contributions from even more people, more than 100 in this project, and we developed this metrics-reloaded framework to align metric choice to clinical interest. And a hard problem in this context was to define the scope. So what we actually ended up with was to say, okay, we want to be agnostic to the image modality, can even go beyond biomedical, but we want to talk about problems that can be seen as a classification problem. So semantic segmentation would be pixel level classification basically, and you can go all the way up to image classification, and then object detection, and object detection is basically something in between. So this is the scope. And then we collected, and this was a community effort, we put this on social media, we collected pitfalls regarding to many different aspects that matter, basically anything, people could contribute anything. You see a few examples. Just to pitch them here, for example, you see that a metric such as a dice is highly sensitive in case the size of your structure is small relative to the grid size. Here you see another example in which, again, the dice is basically not respecting the topology of a structure. So if you're interested, for example, in the center line of a structure, the dice is basically not appropriate. But it's not only about dice and segmentation. For example, here we look into calibration of classifiers, and you see that they're highly sample size dependent. Here we look into annotation related issues, and so forth and so forth. So we collected more than 100 of such pitfalls, and then in a second step we basically abstracted them from the specific modality. So we try to identify the essence of the problem. So for example, is there a high variability of the structure sizes, or is there a possibility to have overlapping or touching structures? So we try to explain this at meta level such that we could become agnostic to the image modality. And then our proposal is as follows. So you have a problem as a user, and then all you need to do is extract these relevant problem properties, which we call a fingerprint. So I will show you how this looks like in a second. And then based on this fingerprint, we basically guide the user towards picking relevant metrics. So no worries, I'm not gonna cover this whole flow, but just to give you a glimpse. The first step again is the fingerprinting. You see it on the very left. Then the next step is the actual metric selection, and you see this for all the different classes, the segmentation, object detection, etc. So we can easily reduce this to, in this case, for example, the classification problems. And that you see from a bird's eye perspective, what we suggest is to select what we call a multi-class counting metric. This is a metric that captures performance in a single score. This is to be distinguished from the per class metrics, which basically look into specific properties for each class individually, and so on and so on. And basically, whenever you see this plus here, plus S2, S3, S4, S5, this means that you have to go through another decision process to actually make the decision. So here's one example to actually pick a multi-class counting metric. So an important decision here, for example, is the question, so is there a class imbalance in your data set? And if there's a class imbalance, do you want to compensate for the class imbalance? So maybe if your prevalences in your data set are exactly matching what you need later, then it's okay to compute things this way. Yeah, so I'm not going to go into this into much further detail, but you see it can be complex, and this is why at some points we also involve the user, so they have these decision guides. In some cases, it's not clear what basically to do, or depends on prioritization. So here, for example, we have a situation that you could choose balanced accuracy, MCC, or ECN, and basically the user is given the pros and cons of everything. And as this is kind of cumbersome, we also provide a tool that should guide users through the whole process. That's on our website. So you have different functionalities here, for example, also a metric library where you can look at advantages and disadvantages of metrics, but here we also have the metric selection tool, where basically step by step you're guided through this decision tree. So you have to answer these questions. For example, are your structures small relative to grid size? Are you interested specifically in the center of the structure? This can be important in cell tracking, for example. Do you have a tubular structure? And so on, and so on, and so on. And then you basically get a recommendation. To help users, we have made several sample instantiations. You see the examples here, and you see that really basically for each of the classes we selected similar problems from different domains. So for example, it doesn't not matter whether you want to segment a cancer cell or a liver. What matters here that is basically you have a large single object that you want to segment, and then a lot of the recommendations depend on these properties. You can also look up these so-called cheat sheets, where for each metric we provide definitions, pitfalls, also recommendations. A little while ago, we submitted a paper. We got this review back. So essentially, one reviewer said, "Okay, you report the DICE, that DSC, but why not, for example, also report on the F1 score?" And the reason is they're identical. So at pixel level, F1 and DICE score are identical. That's why, of course, we didn't have to report them. And DICE and IOU are almost identical. So sometimes people don't seem to be aware of these relations, why we also provide this table of metric relations in case you're using any of the metrics that we dealt with, then you basically can see how they relate to other metrics. Also, we provide a metrics reloaded toolkit, metrics implementations with or without within or not within MONAI, and hopefully this will be helpful also for some of you. Okay, so we started, as I mentioned before, with classification problems in the broadest sense. Now in the pipeline are recommendations for reconstructions for video and also for foundation models. So just to pitch one aspect that is specifically interesting for video is the temporal aspect, of course. And this can, basically has many implications. And one is shown here. So typically when in biomedical, if you want to solve an actual problem, you want to provide a confidence interval for your estimates. In certification of products, this is super important, for example. And that basically gives you the stability of your estimate. And here you see, maybe you can concentrate for simplicity on just this side, but you see that if you do video analysis and you ignore the hierarchical structure of your data, meaning that frames from the same video are of course correlated to some extent, then you can get very misleading results for your confidence interval. So you largely underestimate the uncertainty if you don't account for this hierarchical data structure. And the same can of course occur if you're working on radiological data science and you have somehow samples from, for example, the same patient or even the same scanner or hospital. It all depends on how exactly your data looks. And yeah, as if this was not enough, there's also many new challenges in the context of foundation models. I think we're missing out on a lot of aspects that are not so easy actually to assess in terms of metrics, and there's basically many open research questions. But now I want to take a deep dive into one aspect that I think is super important, and that is completely ignored by many. And I was very surprised that actually we just heard this year that we won the Media Best Paper Award for it, which basically means that there's a special issue from the MICCAI 23 papers, and then basically from those papers that get accepted into medical image analysis, the best paper is chosen. And this was it. And I was so excited about it because this paper is maybe not a traditional paper, but it talks a lot about problems again and best practices and what should be done. And I was super grateful that this was acknowledged by the reviewers. So what is it about? And yeah, I missed actually the two people that are first authors because I showed them on a previous slide. So Patrick Godau and Piotr Kalinowski were the two students mainly driving this project, and it was a collaboration also with Paul Jäger and Luciana Ferre from Argentina. Okay, so sometimes when I ask students, okay, you have a neural network architecture, you have a classification problem, you convert whatever output you have from your neural network into class scores, then what is your class? Which class do you output basically as a prediction for a diagnosis, for example? Then often this question is not even understood because people basically always say you would basically take the highest number, meaning that you use the argmax operator. Okay, I will show you now that this is not necessarily a good idea and what you need to do in order to make this a good idea, if at all, basically. Okay, so to draw broad conclusions, we looked into many different data sets with a lot of different numbers of samples, different numbers of classes, different imbalance ratios. And I mean, you can basically see all the details in the paper, but I will try to bring across the glimpse. Okay, argmax. So what I will show you now is basically whatever we assume we have a optimal classifier. So we basically put the decision threshold. Okay, let's assume a binary case. It's easier to explain. So in the binary case, argmax basically would mean if the score is above 0.5, you go for the positive class, for example, otherwise for negative class. Now, when I talk about optimal threshold, I mean we basically pick the threshold that gives us the best result. So we train our algorithms in a balanced setting, so the binary case 50-50, and now we look what happens when in the test set we basically change the prevalence. So we go to up to the case of 1 out of 10 is basically the positive class. Then you see we actually have a large deviation from the optimal performance when we use the argmax operator, and it's really a large discrepancy. So normally, I mean, and remember these numbers, please, because I will come back to them in a second. Here we talk about a difference from 0.86 to 0.92. This is quite breakthrough, right? If you think of papers that publish something, this is quite a big gap. And this is only because we've changed the decision threshold. Okay, so why is this happening? Well, we've tried to illustrate it. So here, this is the 50-50 case, right? We have a balanced setting. We train our classifier and we basically make the cut at 0.5. Then we have a few false positive and a few false negatives. That's it. Now we change nothing except for the prevalences. And you already see, if now we keep the threshold of 0.5, that's not a good option, correct? So we would need to shift this threshold somewhere here in order to maximize accuracy, correct? And yeah, from a more theoretical perspective, argmax is actually only the optimal decision rule if the predicted class scores are calibrated. Okay, what does it mean they're calibrated? I will explain this with a metric that arguably is not the optimal metric, but I think it's the easiest to understand. So intuitively speaking, what we mean by calibration is if for example, a softmax score is 0.8, then this means that in 80% of the cases, we want this prediction to be correct. In 80% of the situations in which we have a score of 0.8. And to assess this capability, we can, for example, do the spinning, where we put all the cases with a confidence of, in the range, for example, 0.2 to 0.4, we put them here, 0.4 to 0.6 here, and so on. And then we compute the empirical accuracy for exactly those samples. And then we see that, for example, hopefully we're exactly on the straight line, then we're well calibrated, or otherwise we have an overestimation or underestimation of performance. Okay, so first question now is, are the scores calibrated? And yeah, short answer is no, they're not. And what may be more surprising, they're not even calibrated when we basically apply the popular, probably most popular method, temperature scaling, to recalibrate, knowing the deployment prevalences. So we weigh everything according to the deployment prevalences, and still we don't get calibrated classifiers. So why is that the case? Okay, for this we have to dig a little bit deeper into what's happening in the network. So again, you have your raw model logits, then you apply a transformation, which is your calibration. You do softmax, you get a score. Now in temperature scaling, you basically, almost as the name says, you only estimate one single parameter, the temperature T. And one important property of temperature scaling calibration is that it is accuracy preserving. But remember, we actually don't want to be accuracy preserving. We actually want to change the decisions. I've shown you the illustration before. We want to change the decisions of the classifier. So we don't want to be accuracy preserving. And this is why we basically need to add a bias term, as you see here. And now, long story short, when we do this, then we actually solve the issue. So to show you some examples here, two different data sets. We start with a deployment setting which reflects the training setting, 50-50, and you see the argmax threshold is very well aligned with the optimal decision threshold. Now, without recalibration, when we change the imbalance ratio, we actually have quite a shift. But doing the recalibration with the method that we propose, we can actually have the thresholds in very good alignment. So yeah, so again, in this paper, if you're interested, we go through these questions step by step. So we answer the following questions: how well can we estimate prevalences from unlabeled deployment data? So what I've shown you so far was always a recalibration with the known deployment prevalences. Now you can say, well, we don't have them, but we show and I think the results are actually very convincing. We show that we can estimate the deployment preferences from the data itself. And then we show the effects of prevalence shifts on the quality of calibration, the decision rules, and also performance assessment. I didn't talk about this aspect. And we basically propose a workflow for compensating for prevalence shifts. So this is how it looks like in the end. I want to highlight again that argmax, if you use argmax, please use it with care. Make sure that you're working with calibrated scores and reconsider whether it's actually accuracy you wanna optimize, because if you're using argmax, you're implicitly optimizing accuracy as a metric. All right, that's it with the deep dive. Now let's move into the next topic that is important when we do benchmarking and validation, which is baselines. Okay, so if you hear this classifies an accuracy of 97%, I mean, clinicians are typically super excited, it's great accuracy. But in a low prevalence case, which we often have in medicine, you can just guess the most frequent class and get an accuracy of 97%, which is again one reason why also prevalence independent metrics are important and why it is important to understand what is the baseline, for example, of a random classifier. And I want to underline, and this is maybe not so well understood, that in the context of vision language models, all of a sudden we get also new baselines that are important. So, for example, in this work, which was actually led by Paul Jäger's team, we show that the baseline where you prompt a vision language model, but actually without the image, it gives you already very strong results because there's a lot of prior knowledge encoded in the language model. So, and obviously it doesn't make sense to basically ask for a diagnosis without an image, for example. But if there's frequent diagnosis, then this can already be leveraged from a model, for example. So again, we need to take care understanding the baselines and then really improving over those. Yeah, coming to the end of the pipeline. So at some point, you have all your metric values, you have your baseline, you've done all the algorithms. And then what we see a lot is tables like this. This is specifically also a phenomenon of the general AI community. And I'm not a big fan of these tables, to be honest, and I want to show you why. So let's start with the simulation. I'll come to real data in a second. So here we've 5 simulated algorithms. On the left, there's actually a true difference between the mean metric values, and on the right, there isn't. So it's actually the same distribution of the data. And those would actually yield the exact same ranking in the specific example. So already a while ago, we proposed this framework, Challenger, now it's called Rankings Reloaded, where you would see, in this case, due to the bootstrapping analysis, whether a ranking is basically stable or not. It offers also a lot of different functionality. Okay, so this was done a few years ago. Now, what have we done more recently? So first of all, we looked into the question whether we actually have a problem in practice, because of course, if you have infinite sample sizes, then even small differences may actually be meaningful. So we started to look into this by analyzing MICCAI papers from 23 and asking the questions, how are uncertainties in the data accounted for? And as you may know, the regulatory bodies always want basically estimates of the uncertainties along with whatever performance analysis you have, and confidence intervals, for example, are a very important tool in this context. So we asked the question, is uncertainty reported? And in the majority of papers, it actually isn't. And in the cases where it was reported, it was often the standard deviation that was reported, but it was often unclear what the standard deviation was taken over. So was it false, or was it the actual data? And that's actually a huge difference. And sadly, we found that only one paper reported confidence intervals. So I want to recap for you. Confidence intervals basically tell you how reliable your mean or median estimate is. So if you had infinite sample size, it would be 0. But it tells you if you compute with this very method the confidence interval, then in 95% of the cases, your mean would actually lie within this confidence interval. Now, what do we make of it? So it's not reported, but maybe the reason is that the confidence intervals are so small. So what we did next is we analyzed all the data that we could find in the papers. And first question we asked, okay, what is the median difference between a new proposed method and the strongest competitor? And what we found is actually very, very interesting, because we did this for segmentation and for classification, and we found in both cases the median improvement was 0.01. Okay. Now you could argue, if that is a relevant finding, that now we are 0.01 better, then probably the confidence interval should be smaller, right? Because we don't want to have such high uncertainty. But we found that in practice it's actually not so. It's much wider, meaning that we're not very certain about these results. So now you could say, okay, but it's true that the confidence is basically low, so the uncertainty is high. But even then, if two methods are completely in sync, then a small difference could still be meaningful. Okay, so this is why we now use the term congruence. So this is basically what we mean if we have two methods and they have very similar metric values, then we speak of high congruence, otherwise of low congruence. And what we did is we took all the segmentation and classification papers, so more than 300 papers, extracted, this was a big effort, all the metric values that we could find for the proposed method and the strongest competitor, and did a lot of analysis. And long story short, we found, and that's sad news, a very high probability of false outperformance claims, meaning that people, and this is just from, this is very important, this is just from a statistical point of view, right? We're not even talking about the other issues. We found that just from a statistical point of view, there's a high probability that the claimed new proposed great best method is actually not better than the second method. And this does not even capture anything related to data leakage, model overfitting, weak baseline implementations, etc., etc., etc. And we asked the question, so to have a tangible, a meaningful difference when we have a 0.01 difference in dice or in accuracy, how much data would we need? And so just roughly speaking, the answer was we need an order of magnitude of more data. So important finding. So please, when you submit your next MICCAI paper, at least report some confidence intervals. And by the way, we will, I think we will soon release a tool that allows you basically to compute the probability of false claims for your own paper. All right. What's next? Well, this is actually a figure that we generated some years ago, but it should just show you that the instability does not only come from the data, but also from other design choices. So we have to choose the metric. We have to choose, do we first compute metric values and then rank, or do we choose the rank per image and then aggregate, or how do we even aggregate with the mean or the median? And depending on all of this, you can get very, very different results of methods. This is real life challenge data. So please, when you do your validation experiments, think carefully about all these these questions. And I see David is coming up, so I think this means I have to stop, but I think this was already, I can skip this one, more or less it. So proper evaluation requires attention to detail. This was a very important message that I wanted to give you. If I had time, I would have pitched to you our next project, but I won't, so I will pitch it next time. And so I can allow you for some questions. Keep in mind, maybe this slide, sorry, I want to show. No, this was too fast. Yeah. So I think we often, sorry, there's now a delay. Yeah. So I think there's this big question of how we position ourselves in academia with respect to the big tech companies. And I think there's many answers to this, but one thing that we definitely have in academia is the credibility, which is why I think benchmarking is actually a very exciting field also for research. And with this, I want to thank you, my team, and all the collaborators.
Thank you so much, Professor Lena, for this insightful talk. It really sparked a lot of interest. And we have one question here regarding the expected cost. So here they say the idea of EC or expected cost was interesting, but looking at the results, the EC of 30 across both data tests does not change the fact that the performance metrics have decreased. Does it not seem like we're trying to modify the results to fit something that works for us? I'm sorry if I misunderstood.
Yeah, so, okay, first of all, I do think, I agree with the implicit message that sometimes people try to use metrics that make their results look favorable. That is absolutely the case. In this specific case, I think expected cost is actually a very good metric for fixing what I mentioned, which is, so I will not go back to the slide now, but which is the prevalence shift in the data. So you can configure this metric in a way that you will have the same metric value independent of whether you have a change in the class frequency. Notably, this does not account, of course, for other shifts in the data, right? This is just from the prevalence perspective. But there's actually, if you want to look, so I don't see a name for you, but there's a new paper that came out from one of the co-authors, Luciana Ferré, and she wrote a very interesting piece of work, which is also based on all the discussions that we had on classification metrics, which explains a lot of the things backed up with theory from a Bayesian perspective. It's very interesting. I can check if I find it and post it in the chat.
Yes, perfect. Thank you so much. And we have another question. So currently, medical image analysis models like MedSam require explicit prompts to guide segmentation, which limits their ability to autonomously detect unexpected or subtle abnormalities. How do you envision addressing the fundamental challenges of training a prompt-free vision language model that can reliably identify and segment all relevant abnormalities in a medical image without prior knowledge of what to look for? Specifically, what mechanisms would ensure the model does not miss critical findings that weren't well represented in the training data? And how would you validate that the model autonomous reasoning is clinically reliable compared to radiologist interpretation?
Okay, wow, that's a complex question. All right, so let me start with what I know best, which is the actual validation. So I think this person is actually hinting at something that's very important, which is the fact that, especially, I went to CVPR, and what you see there is a lot of aggregated scores, and they don't tell you what is working or what is not working, or maybe there's some sample images of what is working or not working. But I have made the experience that sometimes we have a confirmation bias, so we think that something is difficult, and then we look for images that would show this. And I was wrong in some cases, actually. So what I would recommend to do is to stratify performance for what matters. And I would specifically also recommend mixed model analysis, where you can basically assign images with meta information. So for example, it could be the meta information of the size of a lesion. And then you can in a very statistically sound way, assess what factors influence model performance the most. And you could, for example, find that lesion size is an important factor. But what we always do is that whatever aspects we can extract from with our prior knowledge, for example, lesion size, we stratify performance for these, and then you already see some patterns. Clinically reliable. Well, I mean, you can of course always use a human rater as a reference, or ideally multiple human raters, and then compare performance to them, or see where you stand compared to when you compare two human raters. But the challenge is, of course, when we go beyond human capabilities, right? How do we assess there? And I think then it's becoming actually very tricky. And I cannot comment on the methods development size of the prompt-free models. Also, I guess given the time, it would become very speculative.
Yes, thank you so much. So there is a short question regarding the talk about the data sets. Are there any suggestions for the rare cancers?
Rare cancer data set?
Yes, so I guess specifically when we talk about the EC, so basically we have this long tail problem issue every time which this type of data set.
Okay, this is something, if this was an interactive seminar, I would have liked to discuss with you guys, because we're just thinking of actually providing a tool that can answer such questions, that can provide suggestions on data sets that are already available. So for example, it would be able to tell you about a rare cancer case. I don't know on the top of my head, but I can double check with our database if you send me an email, for example, on this specific question. Yeah. And then maybe, I didn't mention it in the talk, but I think it's maybe becomes relevant in this context. So what we do, so we have a new grant, which it's called MEDAL, Medical Imaging AGI's Last Exam, where, and you can all contribute. We have, if all goes right, the contracts still need to be designed, where we will hopefully have 1 million euro to distribute to the community to share exciting data. So the idea is to assess true AGI, medical imaging AGI capabilities with very exciting questions, where we will also make sure that some of the long tail tasks are basically covered.
Yes, so we have time for a couple more questions.
I just see that. Can you tell if the IMSI lab has openings for short internships, prerequisites? This I can also answer. So I don't know what's meant by short, but in very rare cases, we go below, let's say, 4 months. You can always apply. There's actually an application side. Then we look into the application. You can also approach me wherever. And yeah, then we look case by case, but it's chances are much higher if it's at least 5 or 6 months, because you need to, have some time to get to know everything, and then to actually produce some work. But for example, within the MEDAL project, we will soon have several job offerings. And then maybe, sorry, that because I just see it on my screen. Have you considered extending your study for medical image registration methods? We've heard this method before, but currently we're already struggling with extending to reconstruction problems and image synthesis. This is still in the pipeline, as well as video. And then we also have foundation models in the pipeline. So at the moment, it's on the to-do list, but not on the highest priority list, unfortunately, because there's so much demand for other stuff. Yeah.
Okay, thank you so much. We thank you again for this amazing and thought-provoking talk. I think we can move on for our next speaker. So thank you again, Professor Lena.
About okay. Next, hello everyone. So next session is about challenge and mentoring program, and let me introduce the speaker. So Dr. Antonio Perez. Yeah, welcome, Antonio.
Hi.
Yeah, so he is the associate professor at the University of Colorado, Anschutz Medical Campus, and founder of the Medical Imaging and Machine Learning and Machine Intelligence Initiative. And he is also director of the research program of the pediatric, plastic, and reconstructive surgery at Children's Hospital, Colorado. And Dr. Porras is an expert in computer science, biomedical engineering, and medical image computing and machine learning with diverse medical application and domain, including radiology, cardiology, surgery, and pediatric and medical genetics. Welcome, Antonius, and yeah, please. Yeah, talk about our challenge and mentoring program.
Yeah, thank you so much. So let me try to share my screen and see if this works. All right. Do you guys see my screen?
Yes, we can see your screen. Yeah.
Awesome, perfect. So, well, thank you very much for the introduction, for inviting me to have the opportunity to talk about our mentorship and career advancement initiative within the MICCAI Society. My name is Antonio Porras, and as we just introduced, I'm an associate professor in the University of Colorado. So I just wanted to introduce myself a little bit in this slide and talk a little bit about how or where I work. So I'm at the University of Colorado. I actually have two different labs. I have a computational lab where we develop medical image computing algorithms and machine learning, like a lot of people here are working on or have interest in. And then we also have a clinical lab at the Children's Hospital Colorado, where we work with our surgeons or clinical fellow, and we're very focused on the translation of our methods, which I think it's a very important part of our mission, right? As researchers and scientists, to be able to work on things that may also have a clinical practice in this field. I have been involved with the MICCAI community for quite a few years. I think it's been about 9 or 10 years. I started being involved with MICCAI in about 2015, where I was invited to participate as a member of the executive committee of the organization of MICCAI 2018, which happened in Granada. So in that year, I also had the opportunity to work with Marius Ligrado, the current president of the MICCAI Society, in the creation of the MICCAI Mentorship Program, which at the time was a mentorship program that was tied to the organization of a very specific edition of the MICCAI conference. And then since that year, after MICCAI Granada, we started having our mentorship program every year tied to every conference. And I also got involved in the organization of almost every single MICCAI edition, involved as a chair of young investigators and the early career development program. It was the mentorship program in MICCAI actually got quite success and became very popular. And in 2023, it was actually decided by the MICCAI Society that we would convert this program to a continuous version of itself and kind of like untied from every MICCAI conference edition to make something like a continuous mentorship that could provide support for both mentees and mentors throughout the year. And at that time, it's when the MICCAI Career Advancement Group that I'm representing here today is when it was created, right? So there is an entire working group within the MICCAI Society with a series of investigators, a group of investigators that are working on different career advancement initiatives. And also something else that our group takes care of is we try to raise funds to support attendance in the conference of students from different backgrounds in the US, but also there are also separate from our working group other initiatives that are attempting to raise funds for students from other areas of the world. So the working group currently is formed by 12 different people. You can see here how different parts of the world are represented. We have people from North America, we have people from Asia, from Europe, etc. And this working group used to be chaired by Marius Linguraro, again, the president of the MICCAI Society. But a couple months ago, the leadership of the working group was passed to both Spears Backus and I. He's at Indiana University, and I'm here talking to you on his behalf as well. So our working group has several initiatives, and we have several different pillars. And I just want you guys to be aware of the things that we're doing in the career advancement working group. So of course we have a member of the group that is a liaison every single year with every single MICCAI edition, with every single MICCAI conference edition. So this year for South Korea, we have Anis Kasi, who is like coordinating all the activities that will happen with related to career advancement within the conference. And then next year in Abu Dhabi, I will be the liaison like I've been in previous years as well. Then we also have a member in our working group that is coordinating career advancement initiatives with different other groups within the MICCAI Society. So we have Naren, who is the president of the MICCAI Student Board, the MSB. So he coordinates all the career advancement initiatives that happen with them. Then we have Bella coordinating with the Women in MICCAI group. We have Esther coordinating with RISE, who is, of course, everybody here knows her because she is organizing this summer school. And then we also have Kathleen, who will start to develop educational initiatives also within our working group. And the part that is more important, or that has grown more during the last few years, are the mentorship programs, right? And that's the reason why I'm here. This is what I wanted to talk to you about. So we have our mentorship programs can be divided in two parts. So on one hand, we have what we call the MICCAI Startup Village. This is just a competition for startups, and we want them to have access to the MICCAI community so they're able to not only learn from us, but also we can pair members from our community that are working on startups. We pair them with mentors that have experience in companies like NVIDIA or Siemens or any other big company that can actually help them through advice in growing their companies. But then we have what we call the MICCAI Society mentorship program. So this is just, as I said before, a continuous initiative in which we have successful mentors from around the world that get paired with mentees that are trying to grow their career, and they just have periodic meetings in which they exchange ideas, they receive advice, and hopefully this is useful for the advancement of their career. And something that we started doing recently, I think we've been doing this for a couple of years only, was a specific version of the mentorship program that is tied to every MICCAI conference. And the purpose of this program is a little bit different. We are doing it this year with the Pan-Asian community as part of the Young Scholars program for South Korea. And we are doing this right after this summer school as well, with the purpose of, in collaboration with RISE, with the purpose of helping students who have never been to MICCAI to submit their first paper and get them exposed to our community. So what I have here pretty much is a comparison of the difference between these two programs, because I think it's very important to have this clear. So we have the continuous mentorship program that has been running for about 7 years now, and this is focused on career. So here we're trying to match mentees with mentors with the purpose of helping grow their careers. And grow your career can go from learning how to write a paper or how to find your first job after your PhD. Like, this really depends on your specific goals. And this usually applies for people who are already either pursuing their PhD or thinking about entering their PhD program and really want to get advice outside their institution, for people who have been successful in the area of research and in the environment where they want to grow. That can be academia, but it can also be the private sector, and if they want to succeed in that sector. Usually mentors are going to be always very experienced academic or investigators in the private sector that are part of the MICCAI Society. And this is important because this is a requirement of the mentorship program, is that both mentees and mentors need to be part of the MICCAI Society. They need to be members of the MICCAI Society. Usually we ask them to commit with a minimum duration of the mentorship relationship of 6 months, but usually relationships can last up to 2 years. And of course, these are recommendations. Like, if you have a mentor and after 2 years you want to stay in touch, nobody's going to prevent you from doing that, right? But what's important to keep here in mind is that this relationship is focused on long-term growth of someone's career. And the way we apply to the continuous mentorship program, it's continuous. So there is this expression of interest form. Some mentees and mentors will sign up for the program, and then we will start matching them based on different areas of interest. What is different about the program that I wanted to talk to you a little bit more about, which is the RISE-MICCAI Mentorship Program, is that this program it can be seen as a particular version of the Society Mentorship Program, but this is mostly focused on guiding students through submitting their first ever paper to MICCAI. So of course, what is considered success here is to have a student presenting something at MICCAI, right? That would be the goal of the mentorship program. And of course, because the goal is different, the timing is also going to be different. The duration here is going to be a year. So this program would start right after the summer school. So we would match a student with a mentor that is used to come to participate in the MICCAI community, who has years of experience, so they can guide the students through identifying the problem, writing their first paper, and submitting it to MICCAI with hopefully maximizing their chances for acceptance. So students here, the mentees, are going to be always students who have never submitted a paper to MICCAI before or have never been accepted to MICCAI, and that are participating in this RISE-MICCAI Summer School. And of course, if too many people we have too many mentees, and we'll need to prioritize, and we want to prioritize those people that have underrepresented backgrounds that may not have access to mentorship opportunities in their home institution. Of course, the mentors are going to be very similar. So these are going to be very successful investigators that are either in a university or an academic environment anywhere in the world, or in a company, right? That is doing the kind of work that we do at MICCAI. And the timeline is going to be different. It would start in September, and then it will end at the end of September next year. The difference is, like, unlike the Society Mentorship Program, there is no continuous matching process. So here we are hoping that those that are interested will apply during this summer school, and then matching will begin. And I'll explain a little bit more details about this whole timeline and process in a couple of slides. But I just want to focus on the requirements to participate in the mentorship program. So the first requirement is you have never attended MICCAI yet. Again, the goal of this program is to help you submit your first paper. So we want to focus on those people who have never been in the conference. Something that is very important for us is that we want you to have permission from your home supervisor. So if you're doing your master's or your PhD in whatever university in the world, and you want to participate in this mentorship program with the goal of submitting a specific paper or specific work to MICCAI, your home supervisor needs to agree with it. And this is because otherwise we can have a lot of issues with communication, with authorships, and we want to prevent all these types of problems. Something also that is very important: if there is a project that you want to work on to submit a paper to MICCAI, you're very welcome to do so, but that's not necessary. So one part of the process of mentoring here is going to be the identification of a project. So if you don't have any project, you don't know what you want to work on for MICCAI, that's something that you can actually figure out with your mentor, and your mentor will definitely help you choosing the right project for MICCAI. Now, what do you need to do to apply to the RISE-MICCAI Mentorship Program? Well, the first thing you're going to need is the institution from your home supervisor. As I said, we need their agreement and their acceptance of you becoming part of this program. So just get a letter from them that they sign, where they confirm that you're a student and that they agree with you being able to participate in this program. Once you have that letter, you just need to apply to it. And I think Esther will be able to share the specific process to apply later. Once you have applied, and you have the next step is actually do like preliminary work to make sure that you have some basic understanding and background to be able to successfully work towards a MICCAI paper. So we're going to ask you to participate in a challenge from a previous edition of MICCAI, and that challenge can be a segmentation problem, a registration problem, a classification problem, you name it. So you're going to have to participate in a challenge. We're going to ask you to present your results, and then those will be evaluated together with the rest of the candidates. And then once you have done that, you'll be matched to a successful mentor, and you will have a year to work towards your paper submission and presentation in MICCAI 2026.
Hi, Anthony. I think before we move on to the next, I think there's a lot of questions actually regarding the RISE-MICCAI mentorship program.
Yeah, sorry, I don't see anything, so I don't know if there are questions or not. I only see myself in the screen. So.
Yes, I think it's better maybe at the moment because there's a bunch of questions. So like maybe just clarify if you don't mind, like, or you prefer actually to take care of the questions later.
Oh no, it's perfectly fine.
Oh, okay. So first, I think the question is like master students, like is there any requirement for actually starting like PhD or master? And even there's some person also mentioned the whether it should be a student or not?
Well, the definition of student is very broad, right? And really, like whether you're a student or not, and if you're a master of a PhD or both, really depends on your country and the academic system where you are in. So I think that the answer is as broad as the question can be. What is important is you are in the RISE-MICCAI Summer School, and if you're accepted for the summer school, you probably are a good candidate for the RISE-MICCAI mentorship program.
And also, like, here is meaning that you have never attended the MICCAI as a like first order or some with their own work, or like it's also including some just participate the MICCAI. I don't, yeah.
Well, I think that the purpose of this mentorship program is to help someone submit their first work, right? When we say you have never attended, I mean, if you were once in MICCAI, but you did not send anything, like if you're just an attendee, that's not going to prevent you from submitting your first paper. However, the goal of this program is to help you submit your first work. So if you've submitted or you've been accepted to MICCAI before, then probably you are not the best candidate for this program.
I mean, yeah, thanks.
We do not want to prevent anybody from applying, so I would suggest to apply and then have the committee evaluate those situations in a case by case basis. Because again, as I said before, right, the situation of every person in every single country, every single institution is very different. So we do want to be able to evaluate versus discouraging anybody to apply.
Okay, so we didn't put actually the hard first. Like, I mean, for example, here obtain institution letter of support from your home supervisor.
Yeah.
I mean, maybe there's some student actually doesn't have any supervisor, or even though some maybe, yeah. But
well, if you don't have a supervisor, then you don't have a supervisor, right? We do want to avoid issues of a student working with a mentor and then the mentor getting in some kind of like conflict with the person who is paying a student who was not aware that that student was doing work for someone else, right? There can be very tricky situations. So that's why if you're in a lab anywhere in the world, we want to make sure that your lab is in agreement with you participating in the mentorship program.
Also, I wanted to add, if, for instance, currently you don't have a supervisor but have a project in mind that you want to work and apply to the mentorship, if in the future you get a supervisor, it will be kind of on you the responsibility to ensure that the supervisor is okay for you to have this mentorship program. So we are not asking now the letter because you don't have it, but it's important that you keep it in mind when you apply for a PhD or a master's or whatever, and you have a supervisor. As Antonio was saying, we want to avoid to have any sort of issues with your future supervisor.
yeah, thanks a lot, Antonio. Yeah, please.
Oh, you're welcome to stop me anytime. I just don't see, because the way I have the setup here, I only see my face in the presentation, so I don't see anything else.
Yeah, I will let you know.
Thank you, I appreciate it. Yeah, so for all the attendees, like if there are any questions, just throw them there and I'll go through them with no issues. And if we don't have time, we can even answer by email later with no issues. So something I wanted to do here is to also tell you why you want to join the MICCAI community, right? Because we're talking here about mentorship to go to MICCAI, but why do you even need to go to MICCAI? And I think many of you are familiar with MICCAI, but I do want to like be an advocate for this community because it's really a vibrant community where we bring together like researchers, clinicians, industry leaders from all over the world. And it's really amazing for a student. And I can speak firsthand about this. Like for a young student, I remember when I joined MICCAI for the first time, it's amazing to immerse in a community where like everybody has the same interests than you have. People are really nice. Everyone wants to meet more people, wants to help, wants to collaborate. It really is a unique venue where you can learn a lot and you can grow your career. As long as you're working in the fields of medical image computing and computer assisted interventions, like doesn't matter if you're working on deep learning, which most of you will be nowadays, or you're doing surgical navigation or like computational anatomy modeling, like whatever you're doing, like this is definitely a great community where you can that can help you grow your career a lot. Something that is really cool is the amount of collaborations that come out of the conversations in this conference. Like you see someone presenting their work, after their talk, you go, you talk to them, you identify you have a lot of things in common. You can start collaborations. You can even, like, sometimes students find internships that they can do in their program in summer, go to a different lab in the world for 3 months and then come back. This is super common. This is something that I did, for example, when I was a student. But also, if you're looking for a job once you're about to graduate, like, it's an amazing place where you're going to see a lot of job offers, you're going to network, you're going to meet a lot of people, and really, it's probably the best venue where you can network with people in the field and also get inspired. I think that to me is the most important thing. It's like you just go there and listen what others are doing, and it gives you so many ideas and so many new things that you think about that you can implement in your own project, or can give you an idea for a new project. It really is a unique venue and environment and community. And it's not only about the work, so I just wanted to share some of the pictures. We really have a lot of fun, and it's really fun when you go there every year and you see all those people that you have not seen for a year. So these are just some pictures where here in the center you have a picture of Stur and I with Karim, who was a general chair last year, and Veronica, who we did the PhD together. Like, we all know each other. It's really cool. We have those gala dinners that every year they are more amazing. I mean, you have that MICCAI 24, they're on fire there in Morocco, which is a really cool thing to see. Poster sessions in the conference where you really develop a lot of personal relationships. You learn a lot just by discussing with people about their work, or you presenting your own work. It's really amazing. And of course, you have a lot of fun, right? You see your friends, you go out after the conference, you really bond with a lot of people, and the amount of connections that you make in just 5 days, it's just amazing. And this is something that I really want every single student I have here. I really encourage them to participate in these mentorship programs and submit something to MICCAI and try to go to MICCAI, because it really is a career changing environment. So one of the reasons I'm such an advocate for MICCAI and for the mentorship program is not only because I co-created it, but it's because I was a mentee of it, right? So I remember when I was a student, the first time I ever went to MICCAI, I presented a paper in a workshop, and I remember I was just shaking. It was ridiculous. I was mentored by Alex Frangi and Gemma Piella, like my two mentors during my PhD, and I was shaking, and it was really fun to go there and go through that experience where, like, you just have to be in front of many, many people and talk. And that was the first time ever I did it. But also seeing others doing the same thing and going through the same, the nerves, the anxiety, it was really amazing. And it also makes you feel like you're not alone. Like, sometimes you're doing your PhD or you're working towards a specific thing and you go through all these things and you really think that you're unique, but not everybody goes through the same thing. And it really gives you this environment where you can just develop that empathy and see, like, if others can grow, you can grow as well. And if others get used to speaking in front of 2,000 people, you will grow to talk in front of 2,000 people without getting too nervous. And, I started with a workshop, but then I had a paper accepted after in the main conference. I even got a few awards, both in the main conference and in workshops. And it's just by going to MICCAI, you just learn. You develop so much your career, you make networks. I found my job also in the MICCAI community. So when I finished my PhD with Marius Lingler, I went to his lab for a few years in Washington, DC. And even with him, same thing. We co-created the mentorship program during that time. I also got awards in the main conference and in workshops. And it's really cool as you look back and you see the amount of people you have met during the years and how they have helped you grow your career. And you realize the importance of mentorship, right? And you can see the number of pictures here. So these are all my mentors in my career, and well, not all of them, the main ones. And you can see that they just accumulate, and you end up developing these relationships with people that have been really successful in the field, and you end up becoming just one of them. Like, you learn from them, they teach you, they give you advice. Sometimes you disagree on things, and that actually makes you better, because you just have those relationships that go with you your entire life, and it's really cool. So I wanted to show you, of course, I was a mentee, then I became a mentor, but there's people from all over the world. These are our current pool of mentees. You can see that almost every part of the world is represented. Of course, not every country because there's too many countries, but we have people from all over. I was very sad when I created this map because our South American mentees, they finished their mentorship. So we don't have anybody right now from South America, but that doesn't mean they're not welcome. So if you're in South America, please join the mentorship program so we can put some colors there. But yeah, you can see we have people from North America, from Africa, Europe, Asia, the Middle East, everywhere. And we do want to keep growing this network. So think that before you apply, if you feel in any way that you're different, that you don't belong here, let me tell you, you do belong here. Everybody belongs here. There's someone like you, and if not someone similar enough to you, we want you in the program. If you want to grow in the MICCAI community, we want to welcome you. So what to expect if you get into this RISE-MICCAI mentorship program. So the first thing that's going to happen after you work in your challenge is that you're going to get connected with a mentor, right? And that's going to be based on a set of variables that we're going to ask you during your application to the program. And the next step is going to be to define a problem. And as I said before, you can have a project already, but if not, we encourage you to work closely with your mentor to define a problem, define its clinical or technical significance. What are the challenges? Why haven't it been solved? Or why the solutions we have are not good enough? And make a specific plan of what's going to be your life or your project like between the beginning of your mentorship program and the submission of your work. Something that I really want to recommend you is to establish very clear expectations on the first day you meet with your mentor. And that means define exactly how you're going to talk to your mentor, how often you're going to talk to your mentor, what exactly are going to be your timelines, your milestones, and the timeline to achieve those milestones. And then as you move through your mentorship relationship, you need to be the leader of that relationship. Sometimes students think that when they are being mentored, they need to wait for the mentor to come and tell them what they need to do or what the expectations are. And this is exactly the opposite of what you should be expecting. In a mentorship relationship, the mentee is the leader. The mentee is in a way the boss of the relationship. So it is the mentee who has to set the goals of every meeting, who has to send the calendar invites. If there is any problem, the mentee needs to reach to the mentor and speak up when something is working and something is not working, so the mentor can actually help. Think of a mentor as an advisor. They can only give advice on the things they know. If they don't know, they cannot advise. So the mentee really needs to take the leadership of that relationship and push it, because it is in the mentee's best interest to make that relationship work and to have these papers submitted. Now, during that work, I would ask you to work as hard as you can. And sometimes you will work hard and for some reason you will not have the results you want to. That is fine as long as you're transparent, because you have a mentor. So if things don't work out away, your mentor has the expertise to steer however you're working and push you towards a direction that you are more likely to be successful. And it's very important to keep those things in mind, especially as you're a student and a junior investigator. Things will not always work. You just need to be vocal and transparent about those things. And of course, this is a personal relationship. There is a mentor, there is a mentee. So it's a two-way road, and respect needs to be the most important thing in that relationship. You need to do your part as a mentee. You need to work hard. You need to communicate. You need to lead the relationship. And you need more than anything to be respectful, but not only respectful in the way you communicate, but also with your mentor's time. So every time you're setting a meeting with your mentor, make sure that the goal of that meeting is clear to the mentor so it can actually be effective, because your mentor is busy. Your mentors are amazing. They're going to do their best to help you, but they cannot help you if they don't have a clear direction and communication from your side. So please work on that type of respect as well. And the last thing I want to say is you're going to be working towards submitting a paper to MICCAI, but getting a paper accepted to MICCAI is really hard. And I speak myself, I've got a lot of rejections in MICCAI. And some of you will get rejected, and that is fine. Something that is really cool about MICCAI is that if you don't go to the main conference, you may not even want to try to go to the main conference. It doesn't matter. You may want to go to a workshop or a satellite event. And those are amazing opportunities to have conversations in this little bit, conversations and exchange of ideas and present your research in venues that are a little bit smaller, but where everybody's working on exactly the same thing or almost the same thing. This is amazing just to establish collaborations, but also to get specific feedback about the type of work you're doing. And honestly, it's also a really good venue for you to present something without having 2,000 people in front of you. You may have only 100. That's still a lot of people, but it's not the same. I'd rather present things in front of 100 people than 2,000. I prefer going to satellite events most of the time. I like them a lot. So keep that in mind. If you work towards a paper in the main conference and it doesn't get accepted, there is nothing of failure about it. That actually puts in the majority. Like most people get rejected, but workshops are an amazing venue and a really good opportunity to still make a lot of connections, present your work, learn from your mistakes, and come back to the next MICCAI edition, and that's perfectly fine. So the timeline. So we are here in the summer school, right? We're on July 14 today, day one. So after the summer school, you're going to be working once you apply on a challenge, and that probably is going to be approximately 1 month. And Esther, you can correct me if I get anything wrong in this timeline. Once you finish your challenge, the matching will be done and mentorship will start, and that we are planning for it to be September 1st. And then from September 1st, you're just going to be working with your mentor towards your scientific submission. The conference deadline is March. The satellite events deadline is June. So you can try both. You can go straight to satellite. As I said, both are perfectly fine. And then the mentorship relationship will end within this program on the next edition of MICCAI 26. What is important is, like, if you decide you want to keep in touch with your mentor, that's perfectly fine. So mentorship doesn't have to end. And the one thing that we'd really encourage is, once you finish this RISE mentorship program, please consider applying to the continuous mentorship program, which is more focused on the development of your career once you have been successful in submitting your first paper, hopefully. So that's everything from my side. If you have any questions, I'm happy to answer them.
I mean, thanks a lot, Antonio. Yeah, it was, I mean, many people actually have interest in the mentorship program. Yeah, okay. I think, okay. I mean, regarding the publications, like there's some people say it was accepted for the MICCAI workshop, but not for the main track, but still eligible.
Yeah.
Yeah, okay.
Yeah, so MICCAI satellite events are part of the MICCAI conference, right? They're not, we call the main conference, but they are probably the most popular part of the conference. Like, we have so many people in those satellite events. It's just a way to have people doing more focused work on specific fields, instead of being in a plenary session with something more of interest for the entire community. So we definitely, if you're interested in just a satellite event, we want you to be in the mentorship program, and we want you to work towards submitting a paper. And most of them still get published. So it's a great opportunity for you as well.
I mean, like maybe RISE-MICCAI more prioritized who never managed to actually publish any paper in a MICCAI, right?
Correct.
So even for, I mean, even someone who already managed to, publish in a workshop, like also feel free to.
Yeah, I've participated in a few workshops in my career, and I think they always got published. The ones I participated in, I know not all of them get published in proceedings, but many of them do. So that's something you can discuss with your mentor.
And also, is there any way for graduation project students group to apply if their goal is to make the published paper their GP? Yeah, okay.
I don't think I understand the question.
So like, if there's some student group, like a kind of, because right now the Menti form is for individual. So like, is there any chance to apply for like as a group? And then, yeah.
That's a great question. We've never thought about that. That's something we can definitely discuss.
Okay. Okay. Does MICCAI or RISE-MICCAI have any right to rise over the result or publication produced after completion of the program? For example, if the produced work does not get accepted, can the pair of the mentee-mentor make publication to other journals?
I mean, yeah, of course. It's a mentorship program, right? Like the goal is for you to submit to MICCAI, but if MICCAI doesn't accept it, and you go to a satellite event, and then the satellite event doesn't accept it, which is rare. Like if you're working with a mentor for a year and you don't get accepted in either, the chances are very low that that happens. But if it does happen, nobody, as long as your mentor from your home institution is happy with you publishing with the mentor, there's nothing wrong about it. That's work you did. You should publish it.
Okay. And okay.
Yeah, I think one of the questions that I see that there are a few, it's about the funding letter. So the funding letter, it's mainly for us to understand if you're planning to submit the paper and you get accepted for MICCAI 2026. One of the goals of both the mentorship as well as RISE is try to secure funding for people to come to MICCAI 2026. So therefore, it's very important in this letter that just you state if there will be some funds available from your home institution, for instance, it's possible that they can cover the full or let's say just the registration, and if it will require some sort of funding to attend, because that way it helps us to try to secure money for next year. So this is, if there's not a specific form, it's just for you to describe or to help us to understand which kind of funding you might require in order, if you get accepted for MICCAI 2026.
Maybe the questions asked are probably regarding the LISA challenge. I think people has to be
So
yeah.
if you want to, maybe we can move to it and we can thank Antonio once more for the presentation on the mentorship. Thank you very much. And yeah, I'll let you introduce the next session, which I hope will give you all the details that you need about the challenge.
Awesome. Well, thank you so much, Esther.
Thank you, Anthony.
Enjoy. Bye.
Bye. So next is about the challenge, and then there's Lahime.
Hello, everyone. Yeah.
Nice to meet you. The Lahime Rohi, the received, received a bachelor degree in computer science from Shahid Bahona University of Keman, Iran. And had a master degree in computer engineering, also like in artificial intelligence from the science and research branch, Islamic Azad University, Iran. And she is currently pursuing the PhD degree with the Smart Data Research Group Department of Computer Science and Engineering, University of Bologna, Italy. Welcome, and then please.
Thank you very much. I'm Rahima, one of the LISA organizers, and today I'm here with some other organizers. And unfortunately, we don't have like other organizer because they had like a meeting conflict with other important things regarding our project. So we are here to answer your questions regarding the LISA challenge, the main challenge, and also LISA at RISE-MICCAI Summer School. Okay, so I'm going through the questions here to find one.
I think that some of them, they might not have attended the session on Friday. So I don't know if you can give a 5 minutes overview of the challenge and maybe also the timelines. I know you went through it and we sent everything, but I know that some of them, due to time difference and things, they might not have seen it yet.
Yeah, sure. Do you want me to share
Yeah,
my
maybe
screen?
if you want. Yeah, just can be a 5 minutes overview so everyone is aware. And just for you, just to summarize, this is the challenge that you will need to be working for the next month, as Antonio mentioned, and this will be one of the criteria that we will use in order to select the mentors. The mentees, and pair them with the mentors.
Yeah. I actually just want, because the presentation is really long, so I'm going to just orally explain about different tasks that we have for this year for low field pediatric brain magnetic resonance image segmentation and quality assurance. Actually, the main challenge covers the two main tasks of quality assurance and also segmentation of hippocampus and also basal ganglia. And last year in LISA 2024, we had the segmentation for only hippocampus. And this year we actually covered like another additional subcortical structure, which is basal ganglia. And for the summer school, we cover like only the second task. And we actually specify like some prizes for main challenge and also for the RISE-MICCAI challenge, RISE-MICCAI summer school. And so you can participate in both, but in terms of receiving rewards, so you are, if you get like attended to the main challenge, so you are eligible to receive and win one of the prizes. So you're not eligible to receive the prizes specified for RISE LISA at RISE-MICCAI Summer School. So yeah, it's like an overview of the challenge itself, and I mean the main and also RISE-MICCAI. And I'm going to share my screen to show you some key dates regarding the challenge.
Can you share your screen or?
Yeah, I'm going to share my screen.
Okay.
Yeah. Yeah, I'm going to share my screen. I don't know if you're seeing my screen here. Can you see my screen?
No, not yet.
Okay, sorry. I actually didn't have it ready for now, so I might need more time to share it. Yeah, I think that you can see my screen right now, right?
Now we can see
Yeah.
your.
Yeah, okay, perfect. For LISA 2025, the main challenge, currently we are in the validation phase. It started on July 1st and it will continue until July 24th. And we will have the short paper submission, which is on July 25th. And it's when we have like testing phase opens for those who submit papers. And we will have also testing phase that will close on August 9th, and after which we will evaluate the submitted Docker models on a hidden test data set. By August 29th, evaluation will be completed. And we will also announce the final results at in the satellite session of MICCAI 2025. And when we have like the oral presentation of all the winning teams on September 23rd, and in late October, extended papers can be submitted for inclusion in the workshop proceedings. And also, I can see on the right, the key dates for the LISA challenge at the RISE-MICCAI Summer School, which will be exclusively for you. And the competition starts on July 14th. The validation phase will open on July 21st and run until August 24th. During this phase, you can submit your models as many times as needed to receive evaluation on your developing models for the segmentation task. So in terms of having your models as Docker submissions, we will have the deadline is on August 25th. The top performers will be contacted on September 1st, and the top 3 teams will be announced during the LISA satellite session on September 27th. Actually, the training and validation data are all available at the LISA 2025 website. And if you a participant in the LISA 2025 at the summer school, RISE-MICCAI Summer School, so make sure that you include the password 321_RISE in your data agreement in order to get access to all the data available on the website. And participating in the LISA 2025 offers the opportunity to, present your methods live at MICCAI 2025, and can have them also published in the LISA 2025 proceedings. Yeah, it was like, some introduction about the LISA, the main challenge, and also LISA at RISE-MICCAI Summer School, and also some key dates for it. And I think now we can go through the questions. Okay, so I'm not sure if these are the questions regarding the LISA. I would like to ask my colleague Austin to answer the questions if you
Yes.
haven't done it. Yeah.
Maybe just to clarify, I think the LISA challenge is running in MICCAI this year, and there are two different tracks. One specifically for the summer school, and this you will only need to apply or try to attend if you want to be part of the mentorship program. However, if you want to participate to the general MICCAI LISA challenge, this is a different application. So maybe you can clarify the difference, because I see that some people is asking to join as a group. That wouldn't be allowed for the mentorship program for RISE to be as a group. It needs to be individual, as this will be linked mentor-mentee. However, I don't know if in the general LISA challenge, is it okay to apply as a group?
Yeah, so everyone should register individually for the challenge, and then you're welcome to form teams after you register. Here's a link, I'll put it in the chat, to the RISE LISA challenge specifically. And then, let's see, actually I can only post a link to host and panelist. Okay, so maybe afterward someone can share the link to all the attendees. But currently the RISE-MICCAI LISA 2025 challenge can be found if you just Google Synapse, 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 RISE-MICCAI LISA 2025. On this main page, the RISE logo appears. Maybe I can even share my screen so I can show you what I'm looking at here. So this RISE logo will appear. So that way you know you're in the right spot for the RISE challenge. And then if you want to participate in the main public challenge, we've provided a link to that here. So then you're welcome to also try this as well. But as you mentioned, for the mentorship, it's important to participate in the RISE challenge. And if you do want to participate, be sure that you fill out the user data agreement form, which can be found on the homepage. Once you fill this out, send it to this email listed here, and then we'll approve your registration after you've also clicked to register. So these are the main differences, is that the RISE challenge is specific to this summer school. Again, there's a slight difference between this challenge in that we're only participating for the summer school in task 2, whereas in the main challenge, we have tasks 1 and 2. And the timeline, of course, is slightly different as well, a bit more relaxed for this summer school, whereas the main challenge, if you go to the main challenge you go to the main challenge webpage, you can see that we have 2 tasks more listed in detail. We have a slightly different timeline, which Rahime mentioned we're in the validation phase for currently. And we have a slightly tighter requirement, including the need for a short paper to be submitted in order to qualify for the testing. So some of these things are not part of the RISE challenge. And again, the RISE challenge can be found if you Google Synapse, RISE-MICCAI LISA 2025. If you have trouble finding this, again, I can share the link, but through the chat right now, it's challenging because I can only send a chat to hosts and panelists. So if there's some other way I can do it, please let me
If
know.
you send it, I can post it to everyone.
Great. So I just sent it in the chat to you, I hope. And of course, if you want, you can also copy this URL, any participants.
So you
Perfect.
should
Thank you
have
so
it
much.
now. Yeah.
Does this clarify the difference between the RISE challenge for Lisa and the main challenge for Lisa?
Is there a question about?
Yeah, I see a couple of questions here, so I can start kind of from the most recently posted. So the RISE-MICCAI version of Lisa Challenge has 2 tasks, 2A and 2B. Are we required to work on both or any one? So you can participate in both, or you can participate in one. If you're asking from the lens of RISE-MICCAI, I will default to the RISE-MICCAI organizers for this, but for us as challenge organizers, you're welcome to participate in both or just one. So I'll answer this one. For the RISE-MICCAI challenge, is it necessary to form teams, or is the challenge meant to be completed individually? I think the RISE organizers have said that you should participate individually. Is that correct?
Yeah, it's individual because we are going to have multiple criteria to pair mentor and mentee, and one of them is this challenge. So therefore, if you were as a group, we are not going to be able to differentiate between you, right? So it would be important that you try to attend if you want to participate to the mentorship, the challenge alone. However, if you want to participate in the general track, then maybe it's possible to work as a group.
Yes, you're welcome to participate in the general track as a group. I can say that with certainty. And of course, the link that is being shared right now is in the chat. It looks like it was just posted. So both students.
Sorry, in the meantime, Esther, I don't know if you have the link to put it in the chat for participants to have access to our presentation. I shared it last week, and I remember that you shared somewhere. Yeah,
So
thank you.
Everything is on our website, but I'm going to copy it again now. So you will see the presentation as well as the recording.
Great,
Okay, sounds perfect. Thank you.
Okay, I got a couple more questions here. So if both students of RISE Summer School want to create a team and participate in the challenge, will that be acceptable? So I can say if you want to participate in the challenge at any point, you're welcome to do that as for the public challenge, the non-RISE challenge. So I'm not sure if this answers your question in the sense that you're able to participate in the challenge as long as you send us the agreement. As for competing in a RISE Summer School, you have to participate as a RISE member and participate in this challenge individually. That is the challenge I'm sharing on the screen. But the main challenge, the public challenge here, this challenge, you can participate as a team. So let's go back to the RISE-MICCAI one. Is it expected from the participant to produce a novel deep learning algorithm, or can they take inspiration or help from already published work? Good question. This is up for you to decide. You're welcome to develop your own algorithm. You are also welcome to use other work. We provided in the presentation that is now shared in the chat on YouTube there a brief description of how you can get started very quickly using NNUNet as a baseline model and training this with the data to participate in the challenge. So watch this YouTube video. I would maybe say like 45 minutes, 50 minutes in, we start to discuss participating in task 2, that is the segmentation task, and how this can be done. Sorry, I was trying to go to the segmentation task here, but this was in the way. And how this can be done within the challenge. So again, you have your overview. Task 2 is described here, and whatever methods you choose to use are welcome. You can use even some data that we don't provide as for pre-training or something like this. But you do have to disclose that if you choose to utilize out of project data or data that's not found for other participants. So as long as you're clear with your methods, you're welcome to apply whichever methods you'd like, including if that's a existing method and you're just utilizing it for the challenge.
And just to clarify, if you're applying for the RISE track, you are not going to be allowed to use any other data outside the one provided by the challenge. And this is because we want to be fair among everyone, right? So some people might get access to some data, some other no, and we want to try to make the competition as fair as possible among everyone. So we are asking for everyone to don't use any pre-train, as then it's easier for us to check.
Okay, I apologize
Yeah,
for that. I wasn't aware of that. So yes, if you're doing RISE, then you must use only the data on our website. If you are participating in the main challenge, which is again found from this main RISE main website here, the link to the public challenge, then you can utilize additional data. But for RISE participants, you may not utilize additional data.
And Austin, is there any email that they can contact you if there's a specific questions? They are welcome to always
Yes.
contact us as a RISE. However, if it's very specific to the LISA challenge, yeah.
Yeah, so if you see this email here where you have to send the user agreement, this is also an email where we'll answer all your questions if you have them. The RISE challenge deadlines are found here under key dates. I think Rahim may just answered that.
Yeah.
Yeah, thank you. The RISE-MICCAI version of LISA challenge has task 2A, task 2B. Are we required to work on both? Oh, I think we had this a second ago. So from my understanding, you I believe can work on either. However, you're welcome to work on both of them. It's not required to work on two from the RISE-MICCAI perspective, but I think Esther, if you would mind clarifying that, because I don't know 100%.
Yeah, no, exactly. I think we were going to more focus in the task number 2, but if you also want to participate in task number 1, you are very welcome.
Oh, so sorry. This is for the RISE-MICCAI. We're only providing data for task 2, which is 2
Okay.
subtasks.
Perfect. So yeah.
So they only have to participate in one subtask, that is task 2A or task 2B to be eligible, right?
Yeah, exactly. Yeah.
Okay.
But I guess if they want to participate task 1 in the main challenge, it's also
Yes.
okay.
Absolutely. Yeah, we definitely encourage that too. And task 2A and 2B are both segmentation tasks, which is kind of why they're grouped together here. But you're welcome, again, as Esther said, to work in just one or both. And the prize pool here actually is per task, meaning task 2A and task 2B. So you can, if you perform well enough in both tasks, you can actually earn up to about $400. Okay, here's a question. In order to participate in the challenge summer school, should we create an account in Synapse? Yes, you have to create an account in Synapse in order to register. And we don't handle that account creation. Synapse does this, so if you have trouble with that, let us know, and we can try to help you with Synapse. But if you click to register and you don't have an account, that will be very apparent. It'll come up right away, and then you'll make an account, and then you can register for the challenge. After you register, you'll need to send in this form for approval. When you use the password, that's part of the registration process. So when you send the form in, please provide this additional password so that way we know that you're a true summer school participant. Technically, because this is not private, that is, it's not hidden, the challenge, anyone can kind of find this challenge and try to register for it. So the importance of you providing the password is so we know for sure that you are a RISE student and we're not allowing additional people to compete in the challenge and make it unfair for other students. So as long as you use this password in the email in which you send the agreement, we'll register you. And if you have issues with registration, you don't hear back for 1 or 2 days, please let us know by again sending a message to this email.
Yeah, and I think it's important to note if you participate in the RISE track, we are going to be checking that you also participated on the mentorship, especially for the hours that the LISA is offering, because it's a specific track that has been designed for this mentorship program. So if you don't want to be part of the mentorship program, you are very welcome to participate in the LISA challenge, as it's very similar, the task.
Could RISE help with compute resources?
Unfortunately, not at the moment. We are working for the submission to MICCAI 2026 to try to see if we can secure some computer resources, but it won't be possible currently for this challenge.
Okay. I think again in the chat here there is the links to the YouTube video. That is the recording from Friday that we did that describes the challenge. There's also the link to this website that I'm sharing here. Yes, I'll repeat where we should use the password. So when you send in your data agreement form so that we can approve your participation, and you send it to this email address, lisa.mrichallenge@gmail.com, you will, in the body of that email, just provide the password so that we can ensure that, again, you are a participant and not someone who's found the challenge online and is just registering, because it's not possible for us to know if you're a participant unless you provide us with this password. So we won't let you into the challenge unless the password, we won't let you into the RISE version of the challenge unless the password accompanies your registration user agreement. Yes, it's okay to send it again. And again, if you don't hear from us, or if you don't hear from us and you don't have any approval for your registration after a few days, please reach out again and we will provide some support there. Yeah, the password is just so that when you register, you are registering as a RISE participant. Because again, this technically, this website is public and anyone can go on to this website, make an account and click to register. But we need to know when you send us the email that we should approve your registration as a RISE participant. So the password is there so that no one, so that if anyone tries to register and they're not part of the RISE Summer School, they're not approved. We only want people who are in the RISE Summer School to be approved for this particular RISE version of the challenge. That's what the password's for.
It is important that either you use the same email to register to the mentorship as the LISA challenge, and if you use different emails, please state on the email that you are sending to the LISA challenge that this is the one that you use for the RISE-MICCAI, because otherwise we are not going to be able to pair you or give some details about who you are in a way that we have both registrations and we can link them and see that you are the same person if you're using different email addresses.
Stop screen sharing here.
I don't see any other question in the chat.
Yeah.
Yeah, just feel free to ask your question via email, sending us email. Yeah, thank you very much for giving us the opportunity to introduce once more the LISA challenge and also the platform, making it available to ask their questions.
Yeah, thanks a lot, Laime and Austin. So it's about the LISA challenge for the summer school and also a bit the explanation for the main track, the LISA challenge. So this is all about the day one, and then we are looking forward to see you tomorrow, day two. So yeah, bye.
Bye, thank you everyone.
Thank you.